you. All right, thank you all very much. At this point, I would just like to briefly go over, thank you, go over the agenda. Today is our day one for the meeting. We'll go over activities for each of the project objectives that we did last year. So all activities up till this point last year, and each objective will be presented by the objective leads. As you know, our team is organized into objective teams, and each objective has two people that are objective leads. So the leads will present activities today on and then we will, at the end of all objectives, we will get into the session where stakeholders will present or share their experiences with SWD this year, what they learned from this season, what technologies did they use, and what are their plans for next year. And then we will end this today's session with breakout sessions where we'll split into two groups. We'll split split groups based on East and West Coast. West Coast group will be led by Vaughn Walton and Dave Epstein, and East Coast group will be led by Cesar Rodriguez-Saona. And we will, after the breakout sessions, we'll do about 30 minutes or so, depending on the comments and feedback we get during those sessions. We will then reconvene, decipher those comments during the breakout sessions, and then we'll adjourn for the day. We will reconvene tomorrow, again at 1 p.m. Eastern, 10 a.m. Pacific time. And tomorrow we will go over again objective-wise on each of the objective plans for the next year. And toward the end of the day tomorrow, we will get feedback from a stakeholder advisory board again, and then we will adjourn at 5 p.m. tomorrow. So I would like to thank all of you again for joining us. Let's go ahead and get started with the objective 1, which is implementation of best management practices for sustainable management of SWD in collaboration with grower influencers. And the leads are Hannah Brock, Hannah Levinson, and Vaughn Walton. So Hannah.
Thanks, Ash. All right, let me share my screen really quick. Okay, that should be good to go, but let me know if anything changes. So like Ash said, I'll be sharing objective updates from Objective 1 on research that was conducted this past summer and summer of 2022. Here are our 3 objective leads for Objective 1 and our contact information in case you're interested. I'll share this again at the end in case you need more time to take note of this. All right, so for Objective 1, our focus is on creating best management programs for making spotted wing management more sustainable. And our biggest goal is doing this in close collaboration with our grower influencers. What that means is that a lot of the work we do is focused on developing new monitoring techniques and tools, with the goal being that these monitoring techniques would be very easy to implement and incorporate into your operations. We want them to be easy to use and to provide the most accurate information. And I just want to touch for a moment on why monitoring is so important and why we do highly recommend using these up-to-date tools we're about to talk about. One of the biggest reasons is that spotted wing populations are extremely variable. They change for many reasons, some of which include the crop that you're working in, the location in the country you are working in, as well as the time of year. So since these populations are so dynamic, it's really important that you're continuously monitoring what's going on in your field so that you have accurate real-time information that you can then make management decisions on and act upon. The other reason is that one of the biggest tools for spotted wing control, pesticides, are showing evidence that pesticide resistance is forming in some populations in the US. So as we continue to have high pesticide inputs in the system, there is concerns that it could spread to other populations in the US. And we will hear much more about that in a later objective, so I won't go into much detail other than to say, in addition to concerns about resistance, there's also issues of the economic costs as well as exposure to workers and pickers. There's also concerns that increased pesticide use could lead to secondary pest outbreaks and negatively impact our beneficial organisms. So by providing you these accurate monitoring tools and giving you real-time information in the field, you can make informed decisions on when and where you spray that will hopefully help prevent some of these negative impacts of pesticide use. So the 3 projects that occurred this past summer focused on Objective 1 and especially monitoring that we'll talk about today are salt wash optimization, or the filter method. I will probably default to calling it salt wash. Then using this into developing field realistic sampling schemes, and then another monitoring tool called dry trap adult monitoring. So first we'll talk about the salt wash optimization. So this has been spearheaded by our team in Michigan State. It was developed a couple years ago, and it was first developed in blueberries. And I'll quickly walk through the protocol for this. So the idea is that you would collect samples from your fruit. We just use Tupperware, plastic Tupperware takeout containers. You then soak your fruit in an incubation liquid, which I'll talk about more in a second, for a set number of minutes. After that is over, you then take your fruit from this container, pour it into this funnel that holds the fruit up with mesh to keep it out of the way. You then rinse this with fresh tap water, and it goes into a reusable coffee filter here. And this is what it would look like. So the incubation liquid forces any larvae that are infesting those berries out, and the liquid then collects those larvae. Then as you rinse it, you collect all the larvae in your coffee filter, you dispose of the berries, and then you look under the microscope to count how many larvae are present. You can also identify what instar the larvae are at. And we highly recommend incorporating this into your operations because it is pretty quick and streamlined. And then we'll talk to you in a second about how we've worked to make it even more efficient. But it's also highly adaptable. So you can see it's pretty flexible in the kinds of coffee filters you use. We like these reusable coffee filters shown here. All of that is easily accessible on Amazon or other sources. It's very low costs. We just use table salt and tap water for the most part. So all of these materials are low cost, accessible, and this can be easily scaled up for your needs. So if you need to sample a large portion of your farm, you can easily take more samples and process those. Or if you have a location that's of concern, you can collect targeted samples in that location. So that is one of the reasons why we're really focusing on this technique. So like I mentioned, this was initially developed in blueberries. And so for the past 2 years, we've been working to optimize this to other fruit types to see if there's any steps in this process that need to change so that it provides the most accurate information for all these different fruit types where spotted wing is a concern. So this has been done in collaboration with Michigan and North Carolina. You can see here we've tested in all of these 5 fruits. So in Michigan, we looked at blueberries, raspberries, and sweet cherries. And then in North Carolina, we looked at strawberries and blackberries. And then we looked at all these different aspects of the protocol to see what areas should change depending on the fruit you're working in. I'm not going to go into detail on all of these specifics, but I did want to show you the extent to which we've investigated this and trying to make it the most optimized for each fruit type. So we're still working on writing this up in a more formal report, but we do have some general recommendations. So we tested several different types of incubation liquid. You can see here in this 3rd column. And we found that 1 cup of salt per gallon of water is a really good incubation liquid that forces larvae out of the berries that you can then capture in that reusable coffee filter. I prefer 60 minutes. There's not a big difference we found between 30, 45, or 60 minutes. What I've found is at these lower time intervals, the larvae are still very active, and that can make them hard to count later, which adds time to this whole process. So 60 minutes seems to work really well. Within that funnel, I like using 10 mesh because it keeps out the most debris so that you are able to count the larvae the quickest. And then at the end, this fruit processing, so that would be this step here. So once the berries have soaked and you've poured them into this filter, we have found that running it through fresh tap water in a sink works really well, but it also helps to agitate this fruit and move them around to make sure you're dislodging all of the larvae that are in that sample. So those are the general recommendations, but we have found a few places where it does help to optimize and change this process depending on the fruit type. So when we have collected blueberries and strawberries, we found that once you collect them in the field and put them in the container, if you give a light squeeze to all those berries, not enough to break them, but just to add some disturbance to the surface of the berry before you put them in the incubation liquid, that actually encourages more larvae to leave those berries. So you're getting a more accurate count of the number of larvae in your berries. For raspberries, sweet cherries, and blackberries, we do not recommend doing that light squeeze. And particularly for blackberries and raspberries, that is because those are more delicate fruit, and we've found that there's a lot more debris that gets through into the coffee filter that then increases your processing time. So we're trying to make this as quick and easy for you to implement as possible. So using this salt wash, we are hoping to develop more recommendations on how you can use this and how that then translates into management decisions. So with this in mind, this is an example from Michigan. So what many of us have noticed is that the infestation of spotted wing not only changes depending on the location within your farm and within your field that you're collecting samples from, but that can also change across the season. So what you might notice in this slide is that around the edges of this field diagram, there are darker circles that represents higher infestation levels of spotted wing. So one of the ways that using this monitoring method could help is you can target specific areas of the field that need extra management efforts for controlling spotted wing populations. And you'll notice that in the middle of the field, there was not a detectable spotted wing infestation. So you can apply more targeted sprays rather than sprays across a whole field or your whole farm. So for this project, this was replicated in 4 states across the country: Georgia, Michigan, Oregon, and North Carolina. And you can see that we conducted this work in blueberries and blackberries. The way this project was set up is at each field, we collected samples along the field edge that was adjacent to a natural area, since that is where we are thinking we're seeing the first infestations of spotted wing during the field season as they move from natural areas back into the crop areas. We also collected samples 40 meters into the field to try to get more details on those differences between field locations. And to talk about the results for this, I'll switch it over to Hannah Barak for a few minutes.
Yeah, thank you. And so these are really late breaking results. These are figures that we just put together in the last couple of days. And so what I'm showing you here are from a single location in North Carolina. And this was a location where we had primocane and floricane fruiting blackberries. So we had a lawn harvest period. And so you see kind of 2 bumps here, and that reflects those 2 different harvest cycles. And the reason I'm showing you blackberries is because those were our most kind of long-term data that we had, and because they're our highest risk scenario crop. And so on each of these figures, the edge of the field is going to be in blue, and those interior samples are going to be in red. What you'll see is that, as in most other cropping systems, we have higher numbers of spotted wing Drosophila, whether we're talking about eggs or larval detections on the edges of those fields. And what you're seeing on this slide is, on the left, the total number of eggs per 10 berries that were observed at those 2 sampling locations across the replicated areas at this site. And then on the right, you're seeing the percent of the fruit with eggs. And it's important to think about both of those when we're thinking about what we're sampling, because the total number of eggs tells us across that sample sample what the volume of egg laying activity looks like. Well, the percent of fruit that have eggs tells us the likelihood that any given egg is going to have, or that any given berry is going to have an egg present in it. But what you'll see is that, with the exception of that early blip in egg detection, which occurred prior to insecticide initiation or insecticide application initiating, and before commercial harvest began, we began to see both infested fruit and detections of eggs in berries between 30 and 31 weeks into the year. And Hannah, if you can go to the next slide. When we look at larvae, we started seeing larvae show up between 31 and 32 weeks. And so we were predating our larval infestations by 1 to 2 weeks with those egg samples. And when we look at the number of total larvae present, we, in blackberries at least, again, our high risk crop, see that difference between the edge and the interior ameliorate a bit. But when we look at small larvae, which are more closely related to our egg counts, we again see that separation between edge and interior. Again, really initial coarse observations here, but in general, we see our egg counts predating our larval infestation counts by 1 to 2 weeks. And we also think that that sampling method might have some promise in terms of its timeliness, or its the time required to do it. So it takes less time to look at a berry and determine whether there are eggs present than it does to soak the fruit and go through the entire process. That speaks to Hillary's comment in the chat box. However, the trade-off is you do really need a microscope or really good magnification to see those eggs, and a decent amount of training to be comfortable, particularly if you're talking about blackberries and raspberries, which, as you can see in the slide, have these little fuzzy filaments on top of the surface as well that can make eggs difficult to distinguish. So you do need a greater level of expertise when you're doing egg counts as opposed to larval counts, which, once you get the search image, are really plug and play.
Yeah, and I think you mentioned this already, but we are seeing that egg counting could give us some buffer time between where we're starting to see the larval infestations, and then looking at small larvae versus total larvae also gives you some earlier detection. So these are questions we're going to explore a little further. You can see that we still have some variables that we'd like to play around with so that we can give you some more accurate information. But this is a trend that we do see replicated across multiple states have reported that these egg counting and small larval counting data do give them a bit of a buffer time on when and where they're spraying. So this is something we're investigating further, and we think it can provide some really useful information. We also want to use this salt wash method, maybe combined with the egg counting at the very beginning of the season, to provide some more detailed recommendations on how you can use this to make decisions about when you're starting your applications, where you're applying them, and then how you could maybe adjust your harvest schedule. So that is future directions we're looking at with that research. So the last project I'll talk about is the dry trap adult monitoring. So this was conducted in Georgia, New Jersey, New York, Maine, Oregon, and North Carolina, spearheaded by our team in Cornell. And you can see we did this in blueberries and blackberries again. So this project was set up similarly to the last one, where we selected a field edge that was next to a natural area, and we set up 10 red sticky cards. They each had a Sentry lure attached to them. We checked these cards weekly, and we would replace the cards each week. And also each week when we were there, we would collect a fruit sample and conduct that salt wash method. The idea here is that the male spotted wings, based on their name, have these distinct spots on their wings. So they can be identifiable by the human eye and in the field. And so maybe this could be a good tool to provide a quick estimation of your spotted wing population levels. But we took the fruit samples to see that if the numbers of males on these sticky cards correlated with the larval infestations in the berries, since the goal is really to limit the infestations in the berries, that is the focus of the management. So what we found is that in some states, in some places, we saw this really nice correlation where an increase in the number of males on those sticky cards was correlated to an increase in the number of larvae. However, in many states, and even in some of those same states I just showed at other locations, we're not seeing a very clear correlation at all between the number of males and the number of larvae. So we still have quite a few variables that will be added into this analysis. All of these analyses I talked about today are still in very early stages, so we'll have more updates for you later. But there's a lot of variables that could be playing into this, including crop variety, weather, what's nearby, and especially the insecticide application schedule. Without that information, we don't know why adult populations might have decreased. And so once we add that into our analysis, we can have a better understanding of population dynamics across the season. So here are some directions we're planning on exploring in the future for this summer. Like I quickly mentioned, we'd like to use the salt wash information to create a decision tree for everyone. So based on your infestation level, you would then have recommendations that you could choose to follow once you have that real-time information from the salt wash. We'd also like to incorporate behavioral control tactics in with our monitoring tools, and we'll hear more updates about behavioral tactics coming up. And then we're also looking at investigating the impacts of this management on our beneficial organisms, including pollinators and parasitoid wasps that may be providing biological control for spotted wing, which we will also hear about more in a little bit. So with that, these are our objective co-leads. And we would love for you all to answer a few quick questions with us. So I'm going to quickly stop sharing my screen and share this link in the chat with you all.
I just dropped it in the chat.
Oh, awesome. Okay, great. Then I will switch my screen over to that.
And for those of you guys who have not used a Padlet before, or for whom it's been a while, the way that you can add content to this and respond to these prompts is by clicking the plus sign under each question. That'll bring up a window where you can type your thoughts. If you see other comments in that column that you would like to add information to, you can comment on other people's points that they've added. You can upvote them or add additional information there. And this is really just a way for us to capture your thoughts in a way that's a bit easier to read and refer back to than the chat column within Zoom. And so you can also leave your thoughts in the chat. We can capture them from there as well, but this is another modality for you to consider using. So that will be open and available to you throughout this session and throughout tomorrow's session as well. We're going to use that information to inform our discussion tomorrow. So don't feel like you need to, type everything super quickly right now.
Great. Yeah. So feel free to go ahead and add any thoughts you have there. And then Vaughn, if there's anything else you'd like to say while we give people a chance to fill in some questions, please feel free.
Well, thank you, Hannah and Vaughn. Appreciate it very much. And to all stakeholders, please take some time to fill out this Padlet information. It will help us tremendously in planning our next steps in the project. With this, we'll move on to the next objective, which is objective 2, and is develop economics-based decision aid tools to support identification and implementation of profit maximizing SWD management strategies. And the leads on this objective are Miguel Gomez and Greg Loeb from Cornell University, and Karina Gallardo and Tobin Northfield from Washington State University. So Miguel and Karina, it's all yours.
Thank you, Ash. And I'm going to share my screen. Share. Okay. thank you for attending this presentation. One second, I need to, okay. And my name is Miguel Gomez, and I'm one of the co-leads together with Greg Loeb and Karina Gallardo. And we have other people participating in our project, and you can see the list here. Again, our objective deals with the economics of SWD, and my objective is to give you an update of what we have been done this past year. So just a refresher, what is our objective? Overall goal is to develop economic-based decision aid tools to support the identification and implementation of strategies that allows growers to maximize profits when faced with SWD problems. So in our team, our main task is to evaluate different control strategies, including calendar-based spraying, which is always our benchmark for comparison, to the different IPM strategies that scientists in our group are developing, such as SWD monitoring, fruit sampling, behavioral control, etc. So we pretty much to do valid economic analysis depend on data available from experiments that our colleagues are doing. So the main output in terms of relevance for practitioners and the industry is to take our models and convert them into Excel-based interactive management support tools that can be used by growers. So what is our research progress in 2022? And there are 4 areas of development. One is that we finished, validated, and published an interactive decision tool analyzing the economics of investments in cold storage. This is a post-harvest storage, post-harvest strategy for control, and we focus in this case on North Carolina blueberry growers because it's a promising alternative to control the disease. We also developed, and we have preliminary findings of an interactive decision tool or analyzing investments in exclusion netting, which is especially attractive for production systems such as the ones that we have in New York State for organic blueberry growers. We also evaluated the economics of incorporating fruit sampling as SWD control strategy, and we use data. We work with Vaughn on this, and we use data from Oregon organic blueberries. And finally, we in Washington examined baseline scenarios for partial budgets for sweet cherries and blueberries. So I will give you a brief overview of what we are finding regarding interactive tools to analyze the cost of sorry, 1 second, I cannot see what I wrote. To analyze cool storage in North Carolina for blueberries. So this Excel-based interactive tool provides information on the returns and economics of investments. As I mentioned, does it make sense compared to calendar-based sprays, which is the mainstream way to control SWD. So in this tool, it's interactive, and users can select key input values, and they include the expected market price for the product, the rejection rate of blueberries from buyers if they test a shipment and identify that it was infested. Then we also allow the user to choose the farm-specific production characteristics, including size, yields, etc. And also we take into account the investments in cost of cool storage. So we, in our analysis, include revenue estimation, production cost estimation, annual profits, and we generate a cash flow and a break-even year if investing in a cooling facility. Yeah. So this decision tool is available. It's available in it's available in this in the project website. Excuse me, in the extension website of North Carolina State there, and it's down. You can, any grower can download it. So this is just a glimpse of what the excuse me 1 second of what the 1 second, please. Sorry, I don't know what I'm doing. Okay, here of how the spreadsheet look like. There is a tab in which we explain the assumptions and how do we do analysis. We then indicate growers that they can, or users in general, that they can use the yellow cells to input their prices, the type of is it early season, mid season, or late season blueberry, and what are the levels of infestation, the production characteristics, what is the yield per week during the 6 weeks of main production, the farm size, the cost of production, excluding cooling, and the cost and lifespan of cooling cost. And then we do a series of analysis for the season. This table, for example, is an output from the tool. In this output, we show the per season revenue stream during production, and this is the output that the user will see. This is the time step every 30 days, approximate date, also the risk of rejections based on time of the production season, with cooling and without cooling, the price per pound, which changes over time during the production season, being higher at the beginning and lower at the end, and these are based on market prices or selections from the grower. And then the output per acre with cooling and without cooling, already accounting for losses for Drosophila. And then we do the average revenue per acre with cooling and without cooling. And also we calculated when there is no infestation, to measure the maximum possible profits, and if you are able to using cooling in this case. Okay. We also do a accumulated cash flow at the farm level. So these benefits accumulate over time with depreciation of the equipment. We do an analysis of whether it makes sense or not to invest in the cooling facility when you have a production planning horizon of 20 years, and we find out that it makes sense. Okay, so this is just an example on that. Yeah, we also do partial crop budgets, illustrating the stream of cash flows for the 20-year period, not only within the season but also over time, to assess this capital investment. So this is the type of information that the user can use. Okay. Second part that we are working, and this is just in progress, is a very interesting alternative for, not for all, but for some growers, particularly in New York State and in the Northeast, is the use of exclusion netting for organic production. So again, we develop an interactive, very similar principle, interactive management tool, assessing does it make sense or not to include. Again, in these tools, users can select production parameters correlated to exclusion netting, cost related to organic insecticides, and prices for blueberries, and the different marketing channels, whether it's sold as a UPIC operation or if it's sold through intermediaries. So it's in a little bit, it's slightly different from the one that we developed for North Carolina. So again, the economic analysis includes cost and cost benefit analysis, cumulative cash flow analysis at farm level, and break-even point analysis. So again, this is a tab in which we ask growers to include the production parameters in terms of production, in terms of costs of establishing an exclusion netting system infrastructure, and the use of organic insecticides, and prices, market prices, which are essential to do this. We also have some assumptions there that I'm not going to go into the details. We are still validating, but I'm just going to show you. Again, we do cost-benefit analysis and assessment of cash flows for 10 years, which is what we believe is a realistic lifespan of an exclusion netting system. And then we do an analysis based on those numbers that they provide. In this case, for example, we identify with exclusion netting and using the mainstream organic insecticides, and we see that after year 4, we recover the investment, and then it becomes more profitable as measured by the cash flow to use the exclusion netting. Of course, here we have a caveat, because this is assuming that there is not a tragic event such as a storm that destroys our system. So we need to improve in this analysis to assess eventualities such as adverse weather effects that maybe require more funds to repair the system. But that's what we have so far. Okay. I will close the video because I think I'm not having a good one second. I will close the video. Okay. Then okay. Sorry. So our third component deals with the analyzing the economics of incorporating fruit sampling in the toolkit of SWD control. So we, in particular, compare the economics of using fruit sampling vis-a-vis other control strategies in the decision-making. In particular, we evaluate fruit sampling in 4 scenarios. One is our benchmark of calendar-based spraying. The strategy 2 will be adult trapping to trigger sprays. The third one will be just fruit sampling to trigger sprays, but the other one will be fruit sampling that affects decisions on early harvest. And we focus on organic blueberry production in Oregon. We develop a quite nuanced bioeconomic model, which I'm not going to go into the details about, but it includes the SWD population dynamics of survival and the transition of the SWD population birth and migration. And we consider 3 stages of in the lifetime of the FWD, including the egg stage, larva, and adult. And expected total profit, because there is a lot of uncertainty here. So we use a probabilistic bioeconomic model, are decided by monitoring costs, spraying costs, and infestation levels, and the berry prices if rejection in the market. So we conduct a series of simulations to test this model. These are our findings when we compare the 4 strategies: no monitor, simply spray, strategy that give us a total profit for the type of farm that we are considering of a little bit over $100,000, and you are spraying 21 times, as you can see here, and you harvest 9 times. When we have a low, what we call low precision monitor, that means adult trapping, in which we observe adults and we spray if we observe any presence of adults, we get a little bit higher returns, 119,000. We definitely reduce the spray times to 11, almost by half, and we don't alter the harvest times. With strategy 3, which includes fruit sampling, the profits are comparable to adult trapping, and so they are slightly higher for this particular configuration of farms, and the number of sprays is 11 and total harvest time. So the winner strategy will be the use high precision monitor, is the fruit sampling, and early harvest. As we say, early harvest, observe egg and larval, sprays observe and harvest on the next day. We do more harvesting here, but it provides the highest profits, substantially higher of 136,000, which are quite high compared to the benchmark of just spraying and to other IPM strategies. So those are our findings. We are working on validating the scientific results of this before developing an extension bulletin. So these are more of our simulations. And here is the strategy number 4. It always gives us the greatest revenue, but there is a little bit of uncertainty, as you can see here. So we recognize that. We do sensitivity analysis, and I'm not going to go into the details, but it's basically what is the threshold used by growers to trigger sprays. And in any case, we see that the spray after some fruit sampling with early harvest is the winner strategy in general. So I'm going to skip this too. And then, Karina, if you are here, you may want to give yourself an update on for blueberries and sweet cherries in Washington.
Okay, Miguel, thank you. So in Washington, we have been working on, first of all, developing baseline enterprise budgets for sweet cherries and for blueberries. In sweet cherries, we completed this last year. We have 4 new enterprise budgets for different varieties of sweet cherries. We guided the choice of these varieties based on the harvest time, and that will dictate how many sprays pre-harvest and post-harvest are needed, right? So early harvest varieties for the state of Washington, like a Chelan, has less pre-harvest applications and more post-harvest applications compared to a Sweetheart, which is a late season variety harvested in Washington, which will have more pre-harvest applications and less post-harvest applications. So based on these, also, we collected data on different pest pressures okay, for spot wind Drosophila concentrated on the fly. And we have what will happen, what type of sprays, additional sprays will be needed if there is a history of high pressure in the orchard for an early variety like Chelan, and a history of low pressure, and then the same for medium harvest time like a Bing, and a late harvest season for sweetheart cherries, right? So high press pressure and low press pressure for that, and what is the different applications, different number of applications, additional applications that are needed when the high pressure is high, and so on. Now, how do we plan to use this data? We have been talking with Betsy Beers and Tobin Norfield, and Tobin, I believe, has data on some effectiveness or efficacy on the use of Extend Day for control of spot wind Drosophila reproduction, I believe it is. Well, I don't know the technicalities, but is the use of Extend Day to kind of like decrease the incremental reproduction of spot wind Drosophila and sweet cherries. So he has data. We are going to apply this data on these different scenarios that we are collecting. Betsy also has data on the mortality efficacy of some chemicals that we also are planning to apply on this. So this is work in progress so far on cherries. Thank you. Next slide, please, Miguel. Oh, no, I thought there was a slide for blueberries. So on blueberries, with the help of Chris Benedict for Western Washington and Wenho Heisel for Eastern Washington, we developed two sets of blueberry enterprise budgets. Western Washington mainly considering conventional production methods of blueberries, and Eastern Washington mainly considering organic production methods. Here, I will have to go back to Wen and Chris potentially to see if there are any integrated pest management practices that are being applied in the state of Washington. So far, with my conversation with growers, the additional monitoring, yes, they do. It is being considered as a baseline practice right now. Sampling or cold storage, I have not heard them talking about that. Netting, not very convinced about the efficacy of netting for control of SWD in blueberries here in the state of Washington. So far, that's what I got. That's all. Thank you, Miguel.
Thanks, Miguel and Karina,
Thank you.
for a detailed update. At this point, do we have any questions or comments for this objective team? Hearing none, I guess we can move on to the next objective, which is objective 3. It is to evaluate sustainable alternatives to insecticides for long-term SWD management. And this objective is led by, it has actually two components. One is biological control and other is behavioral control. And biological control component is led by Kent Dana out of UC Berkeley, and behavioral control component is led by Cesar Saona from Rutgers University. We'll start with the biological control. At this point, Kent.
Great, thank you, Ash. So we're going to look at classic biological control. The SCRI team has looked at both native and imported natural enemies. And there's a lot of participants in this objective, as you can see right here. There's actually even more than this. And that reflects that we're now going from a research and development into an implementation phase. So what I'll first do is give kind of a brief history of how we got here, how we got to the natural enemies that we're using right now. As I mentioned, we started off in the very beginning looking at native predators and parasitoids, and we saw that they were not going to give us the needed control. And so that opened up the idea to do classic biocontrol, the idea of which is you go to the area native to the pest, spotted wing Drosophila, in this case, Asia, and you find co-evolved parasitoids. You look for natural enemies that work in conjunction with the pest biology, and you bring them back to the United States for releases. And these are just photos of some of the folks that worked on the foreign exploration in both China and South Korea. And this was an international effort. Spotted wing is not just a US pest, but it's been found throughout the world now. So the folks we collaborated with were from the US, both college and USDA, a group in Cabby, Switzerland, and a group in Italy. And of course, our collaborators in South Korea, Japan, and China that were incredibly important in helping us find sites, collecting with us, processing material, and actually collecting and sending material to us as well. So from this foreign exploration, we found 19 different parasitoid species that were either attacking spotted wing or very similar species to spotted wing, some of which, like the pupal parasitoids, Pachygropoideus and Trichopria, we already had in North America. So the process at that point is to find out what natural enemies were really common and having an impact in Asia on spotted wing densities. And when we looked at that, we found that 3 species seemed to be important: Ganaspis and Leptopolina. These are both Phygitids, and Acebara japonica, which is a braconid. And you can kind of see the Phygitids look the same, and they look different than the braconid does. The 2 top pictures look the same. So the next process is taking this material into quarantine. In North America, this was mostly done on the West Coast in UC Berkeley. We also had help with taxonomists, Matt Buffington, and our Italian colleagues. Really what we're trying to do in quarantine is to screen material before it's released into the environment. So it's kind of a check to make sure that they are going to attack spotted wing, they're going to have an impact on it, and most importantly, that they do no harm. So we do things like look at the daily offspring production, look at the percent female offspring production. And for the 2 Phygitids, Ganaspis and Leptopolina, they were quite similar to each other. So a bottom line from this one part of the study is that both Ganaspis and Leptopolina, 1 adult female, would kill about 100 spotted wing Drosophila. And we get about a 50-50 sex ratio. So knowing that, you can kind of work out with mathematical models that they should have a fairly good impact if they can reproduce like that in the field. So with these different types of biological evidences, we initially applied for a permit in 2016 to release Ganaspis, noting that there were 2 strains of cryptic species, which are called G1 and G3, and Leptopolina. Well, that first permit didn't go through. This is just looking at non-target impacts, and we can see Acebara, all those bars of all those different fly species, Acebara attacked pretty much everything. Leptopolina in the middle attacked a fairly large range, and Ganaspis, and this is a combination of G1 and G3, had a much more limited range of what they would attack. Really, they focused on the Drosophila melanogaster group, which includes Suzuki'i. And in fact, the G1 strain really only attacked Suzuki'i, and that was work that largely came out of our colleagues in Cabby, Switzerland. So we then applied for this new petition that really focused on only Ganaspis G1 strain. And tomorrow, Shin King and Kim Homer will give an update of where we're at with the different strains being maybe cryptic species and how we can tell those apart as well. So we applied for this permit. It was approved in August 2021 for releases to begin with only this Ganaspis G1 strain or cryptic species. During this time, while we're trying to get these permits developed, We also developed rearing methods for the Ganaspis species, Ganaspis brasiliensis. So we sent those rearing methods off. People are using that throughout North America right now. And I think all the labs are improving on these different rearing methods, doing a little bit of changes for what works best for them. A group of the SCRI members and others also developed sampling programs. Just like we heard from Hannah underneath the first objective, we thought it would be great if we could sample in a similar manner so we can compare results between the different states on our recoveries of the different wasps. And I suppose not surprisingly, but while this was going on, while the permitting process was going on, we found that Ganaspis and Leptopollina did, in fact, they were found in North America, starting in Canada and then in Washington. So we also wanted to look for adventive populations of Ganaspis and Leptopollina. So that takes us to where we are today. In 2022, we developed release permits for 19 states. Those are shown in green. And we developed regional insectaries, and those are shown in the red dot. The regional insectary idea of that is that we'll mass produce the Ganaspis G1 strain, and then we can send it to collaborators in other states that may not have a regional insectary operating there. In 2023, the first thing we're going to do is to develop permits for those states that are now wanting to have spotted wing released there and kind of fill in those blank areas. So wherever spotted wing is found, we want to have a release permit for that state as well. We've also got these adventive populations of Ganaspis and Leptopollina that were found in the Northwest, Washington. And so we wanted to see that movement, and I'll talk about that as we move forward. We wanted to see their movement across North America as well. And we also want to study the regional impacts of climate and host plant availability on parasitoid establishment. So what I'll do now is I'll just go through some of the work that's being done with the Ganaspis releases, going from the northeast to the north-south, moving west across the states and going from the northwest to the north-south. We'll start in Maine. Phil Fanning and his group. Ganaspis colonies were started in 2022. They did releases in 4 organic untreated sites, about 400 adult wasps in each location, and they did pre and post-release sampling, either with putting out sentinel fruit or collecting fruit and rearing that out to see what levels of parasitism they found. They did find post-release at 2 of 4 sites, they had some spotted wing parasitism, but most of that was the Leptopollina, so the adventive populations. That's going to become a theme as we look at all the different states. Also, in conjunction with Maine, New York, New Jersey, North Carolina, they were conducting overwintering studies with the Ganaspis. Basically, what they're doing is they're in colony, rearing out Ganaspis, getting it to a pupal stage, and then going out into the field and putting that into the ground, pupal stages into the ground, and looking to see, assessing the diapausing prepupa and what levels of Ganaspis they're getting in the spring. What's the survivorship? It's going to become a theme as we look across the states that in the West, our worry is hot, dry summers, and the Northeast, our worry is overwintering temperatures, how that will impact Ganaspis and Leptopollina numbers. In New Jersey, Caesar's team is working on Ganaspis releases as well, and he released at 5 commercial blueberry farms. They released about 1,000 Ganaspis, the G1 strain, at each site in non-crop habitats close to these blueberry farms. Similar to others, he's using these sampling programs where they're looking both at collecting fruit and putting out sentinel fruit as well, fruit that's been pre-infested with spotted wing Drosophila. They're looking at these traps placed out there. for once a month for about 5 days with 6 traps per site. That's what the photo is showing in the upper right. And they look at pre and post sampling levels. Here's what they found at these 5 different sites. We can see July, August, and September samples of flies in orange and in blue wasps. What they found was that in 4 of the 5 sites, they recovered parasitoids. They're getting the parasitoids identified right now, but I believe that they believe that most of what they're recovering is the Leptopolina, but they're checking on identification to verify this. New York, Greg Loeb's group, he's working releasing Ganaspis at wild habitats near blueberry farms. He's got 4 sites. He released 600 Ganaspis at each site. And we hope in 2023 to be releasing far more at all these sites as our colonies and our methodologies are getting better. He has recovered larval parasitoids, and it looks likely to be Leptopolina. In 2023, he's going to do more releases of Ganaspis at these same sites and continue surveys for the released Ganaspis and the adventive populations of Leptopolina. Like Phil is doing, he's also studying overwintering survival of Ganaspis. He's also looking, his team's also looking at the relationship between Ganaspis establishment and surrounding landscapes and the effect of repellents on Ganaspis and Leptopolina behavior. Mid-Atlantic states, this is work with Xinqing, Kim, a whole group from Pennsylvania, Delaware, and Maryland. Ganaspis, first thing I have to mention that Xinqing is one of the labs who's been mass rearing Ganaspis and sending starter colonies out. And so Xinqing sent starter colonies out to 9 different states, 12 different labs, a total of about 2,000 wasps to these labs to start their colonies. He's also been working with producing Ganaspis at the Biological Control Research Unit, USDA, and doing releases in Delaware, Maryland, and Pennsylvania. They are sample releasing and sampling at 3 sites in Delaware, 3 in Maryland, and 1 in Pennsylvania. Fairly intensive fruit collection. And Leptopolina was found pre and post release at all sites. We can see on the map to the right, the release area. And he's also recovered Ganaspis. So that's the first Ganaspis recovery at release sites being reported from our efforts. So he's found it both in Delaware and Pennsylvania and 1 site in Maryland. So that's great news. It is getting out there and being recovered. The group is also looking very closely at not just parasitism recoveries, but parasitism ranges. So in these different samples, he's found up to 79% parasitism, 70% parasitism in Delaware and Maryland. That's great news. And he's looking at the association of parasitism with different host plants at these different release sites. So not just host plants with % parasitism, but where's Leptopolina being reared from and where's Ganaspis being reared from? That's going to become critical for future release efforts across the states. North Carolina, Hannah Levinson with her crew, we just heard from Hannah earlier underneath Objective 1. They've got 3 release sites for Ganaspis. They've been making releases, but to date, they've not recovered Ganaspis from these release sites. Also working in conjunction with the other teams at overwintering with Ganaspis. They found low levels of overwintering survivorship using the same methodology I described that Phil and the group in New York with Greg is doing as well. Similar to the other sites, they have at 5 sites recovered adventive populations of Leptopolina japonica, which is also great news and very interesting. Now moving west, Michigan, Rufus and Steve, they've been looking at baseline populations of parasitism in wild fruit and blueberry fields in West Michigan. They've been sampling using the methodologies described, as I mentioned earlier, developed by the SCRI and other members outside. They've made releases of Ganaspis at 6 blueberry fields and 3 cherry sites, released about 300 wasps per site, and did the fruit and sentinel trap collections pre and post release. One of the things they found, this graph is showing a number of different host plants, infested plants that they were collecting from. Leptopolina was reared out. Again, that theme is continuing. Leptopolina is being reared out at most of these sites. So Leptopolina was being reared out throughout the season. More spotted wing collected meant more wasps emerging. That's also important because it means the parasitoids are tracking the density of the spotted wing. They looked at seasonality, so they found low spotted wing infestation on the earliest ripening fruit, low wasp emergence until July to August, and then emergence of wasps started to increase. Wasp emergence lagged behind spotted wing emergence, and at the Ganaspis release sites, they really have only detected Leptopolina at this point, but they are going to double check the identification of the wasp collected. A lot of work going on in Washington and Oregon. Remember, this is where we first started getting the advent populations of Leptopolina and Ganaspis. So Betsy and her team have been looking at these advent populations. So before Ganaspis was being released, they were surveying for wasps. They looked in Northwest Washington at 33 sites across 4 counties, sampled primarily Himalayan blackberries, recovered parasitoids at 23 of 33 sites. 4 sites had Ganaspis only, 7 sites had Leptopolina only, and some sites had both. And this is just an example of the sites. Most of the material coming out was Leptopolina. About 11% was Ganaspis from these different sites. So similar to what they're finding on the East Coast, Leptopolina was the dominant parasitoid in most of their collections. They also sampled in Southwest Washington, and at 3 of 8 sites found Leptopolina only. And in Eastern Washington, found Leptopolina in 4 of 4 sites. In Washington, they are rearing and releasing Ganaspis, the gene 1 material. No releases in Western Washington because of the advent of populations. So they're releasing at other sites, 1 blueberry site, 1 cherry site. And to date, I don't believe they've been any recoveries, but this is just starting. Oregon, Vaughn Walton, Jana Lee, Gabrielle Marie, a lot of work going on there. They've had quite good production of material. 8,000 Ganaspis have been released at 4 sites from June to September, monitored using infested fruit and sentinel traps as others have done. No recovery of Ganaspis at this time, but a recovery of Leptopolina. They have been doing cage studies as well, looking at the density of spotted wing in the cages with the recovery of Ganaspis. So what's good to note is in these cage studies where they are releasing Ganaspis, they are recovering Ganaspis. So it means in that area, that climate, Ganaspis is able to attack oviposit and be recovered. They did find in the mid-density level, 20 spotted wing per female, they got quite high recovery. They got better recovery with 65% of the material being collected being Ganaspis. California, Brian and his team doing a lot of work in the Salinas area, Santa Cruz County, released about 2,000 Ganaspis in 3 counties altogether, Fresno, San Luis Obispo, and Santa Cruz. Releases of Ganaspis in Watsonville are actually right across from the original find of spotted wing all those years ago, and like others, releasing from about June to October. Their releases are in caneberry sites next to natural habitats with wild blackberry, monitoring using infested fruit, sentinel traps. To date in California, no Ganaspis or Leptopolina have been found pre or post release. Ganaspis was recovered from field cages, similar to what Vaughn was doing. Ganaspis has been recovered from field cages where they put in spotted wing, put in Ganaspis, but at low percentage parasitism rates. So to conclude, I'm going to kind of summarize my thoughts of what's going on across the US. What you're probably thinking is, wow, Ganaspis recoveries are pretty low. And that's true, but we have to remember that the material we've been using has been in colony for about 5 years. It's a weakened version. It's a version that really has become kind of a lab rat, so to speak, reared at 80 degrees, 78 degrees temperature. What we should be doing is collecting the Ganaspis material from our releases and putting it back into our colonies to reinvigorate the health of the material we're releasing. You might also be thinking, boy, Leptopolina, we're not releasing that, and that seems to be doing better. Yes, that is what we were seeing at this point in time. Remember, we wanted to get a permit for Leptopolina. It's a good parasitoid, but it has a larger host range. And so we weren't able to get a permit to release this because it has got some potential non-target impacts. But I want to point out from this graph that in most of our Asian collections, Ganaspis, a combination of G1 and G3, but primarily G1, was the dominant parasitoid. So we think that in time, Ganaspis will catch up with Leptopolina, and maybe, depending on the level of spotted wing you've got compared to things like melanogaster, it may take over. And tomorrow, to conclude, tomorrow Shin King and Kim will discuss these differences of Ganaspis G1 and G3, the importation of new material, and some of the specific details of their releases in Delaware that might help with releases across North America in 2023. So with that, I'll conclude. I'll stop share. And I think we should be good.
Thanks, Kent, for the detailed update. Do we have any questions for Kent? We still have a couple minutes for questions if there are any.
And I can answer anything in chat if people want me to. Great, thanks.
Thanks, Kent, again, appreciate it. Let's move on to the next update on behavioral control, which is going to be led by Cesar.
Can you hear me, Ash? Okay.
Yes, we can hear you well and see your slides.
Perfect. So thank you, Ash, for the introduction. And my name is Cesar Rodriguez Saona, and I'll be talking about the sub-objective 3.2. This is on behavioral control. So this is the team of researchers working in this sub-objective and their institutions. As you can see, it's a large number of researchers that have been interested in this sub-objective and has been working together to develop new behavioral-based technologies for spotted wing. So the goals of this sub-objective are to develop novel behavior-based strategies to manage spotted wing Drosophila, and also to evaluate the existing behavior-based strategies for managing this pest. With the ultimate goal that we hope to reduce the number of insecticide applications and reduce the potential residues of insecticides on fruits. So the technologies that we have been evaluating combine different types of stimuli that Spotted wing Drosophila uses to locate their host. They include attractants, chemical cues. Also, they contain phagostimulants, feeding stimulants, and also some of them contain visual cues, and also some of them contain an insecticide that is mixed with these cues to attract and kill the flies. So one technology that has been tested by our group, actually was developed by our group, is this food grade gum. This is a technology that was developed from Von Walton's group at Oregon State University. We have been also, for several years, we have been working with SCRI Technologies on developing an attract and kill technology for spotted wing. We started with a formulation called Hook SWD that contain an attractant, a phagostimulant, and an insecticide. But more recently, the company has developed a new formulation called ACTRA that contains only the attractants and the phagostimulants, but not the insecticide. So it works as an adjuvant, so the growers can mix this formulation with any insecticide and apply it in their crops. More recently, we have been working with a new product that is registered in some countries in Europe. It's called Combi Protect. It also acts as an adjuvant. So it's a phagostimulant. It does not contain an attractant. It just contains a mixture of plant extracts, sugars, proteins, and growers can also mix this product with an insecticide and do regular sprays with the insecticide and this Combi Protect added to it. So just to give you like a brief summary of what our team has done so far or has done in the past. As I mentioned, like we have been testing this food grade gum, or also called Decoy. This is a technology that is based on a gum that is applied to a cloth that is placed in throughout the field, and this gum competes with the fruit for as oviposition sites for the females. So the females, instead of laying eggs in the fruit in the crop, they are going to be laying their eggs in this substrate, this gum. And the earlier data that was obtained by the group at Oregon State showed that in several different crops, this food grade gum can reduce the level of oviposition, the number of eggs per berries. You can see in the control with no gum applied, or with the gum applied, you see a reduction in oviposition in several crops, but also it can reduce the level of fruit infestation. We have been testing also this formulation, ACTRA, as I mentioned, is it acts as an adjuvant. You can mix it with an insecticide. It contains an attractant as a chemical cue, and also it has a pinkish reddish color as a visual cue, and also has phagostimulants, and you can mix it with an insecticide to attract and kill flies. So we a few years ago, we conducted choice studies. This was done in collaboration with the University of Georgia, with Ash's group. Arun was doing a lot of this work, Bamboo. And what we found was that we tested two formulations of this ACTRA. One formulation was the OR1. You can see here with on the right side of the graph in combination with the Entrust. And we compared that with just fruit with water. And we did this in choice arenas where we release flies and give them the choice of either the ACTRA with the Entrust or the fruit with water, sprayed with water. So, and we did this with in blackberries, strawberries, raspberries, blueberries, and just water. So, so as you can see, for this formulation, for the OR1, the fruit, all the fruit that we tested was more competitive, was more attractive to Spotted wing Drosophila than the OR1. So in the presence of fruit, the flies tended to prefer the fruit than the ACTRA formulation. We did the same study using another formulation, the TD formulation with Entrust. And you can see that the TD formulation was more competitive, especially with blackberries and strawberries and blueberries. There was equal attraction to the TD formulation compared to the fruit. However, the raspberries, we know that the raspberries are highly attractive to Spotted wing Drosophila, and they outcompeted the TD for attraction. So this, the data from the previous slide and these data have already been published. So more recently, a couple of years ago, we approached Andermatt, this company that produces Combi Protect, because there were some studies that in Europe that were showing that it can reduce infestation and residues in fruit when insecticides are mixed with this phagostimulant. So we wanted to test this Combi Protect, this product. So I approached the company, and the timing was perfect because the company was actually interested in introducing this product into the US at that time. So they were very interested in working with us towards that. So in 2021, we conducted studies. These were all done because the product is not registered. All these studies were done in research farms, and we conducted studies in cages, in large field cages, where we treated the plants with, you can see here, we treated the plants. We had the control plants with no insecticide. We had plants in the cages that were treated with delegate. We had plants that were treated with delegate in combination with a full rate of delegate with Combi Protect, or delegate at the half rate with Combi Protect. So this data is from Oregon, and you can see that that delegate either at the full rate or half rate with the Combi Protect provided good control compared to the controls. So this data is from New Jersey, very similar results. Here is the delegate at the full rate or the delegate at the half rate with the Combi Protect. Again, provided good control compared to the control. This data is from Maine, very similar results. This is pre-treatment in black, and post-treatment in gray. And you can see after the treatment, the delegate at the full rate or half rate with the Combi Protect provided good control. And similar results were found in New York. So, so we were interested in continuing these studies and doing a more field work. So in 2022, we conducted a semi-field assays where we treated bushes in the field and then brought the treated material in the lab. So we placed the treated material in these containers. So we placed a terminal inside the container with fruit, and then we release flies and expose them to different treatments. So we had an untreated control. We had the insecticide at the half rate, an insecticide program at the half rate plus the Combi Protect, and the insecticide program at the full rate with and without the Combi Protect. So the program that we used was a rotation of different insecticides. So this included Imidan, Mustang Max, Malathion, and Delegate. And so we collected, again, fruit and foliage from the bushes after treatment, after these weekly treatments. And then we place them in these containers and release flies in the containers and look at mortality or counted the number of eggs, and also looked at the number of adults that emerged from the fruit. So these data are for adult mortality for New Jersey. This just to walk you through the different treatments. Here's the control. This is just the Combi Protect alone. These are the half rate of the insecticide with and without the Combi Protect. These are the full rate without and with the Combi Protect. And this is for Imidan. And we did that, we did residual assay. So we looked at 0 days after treatment. So the day that the insecticide was treated, was applied, and also 4 days after application. And you can see that there's some benefits, especially here at the 4 days later. You can see at the half rate with the Combi Protect, it performed better. The Imidan performed better. Here is with Mustang Max. Again, there was some benefit. You can see at the half rate and also in the full rate, you can see an improvement, at least numerically. With the Combi Protect, here also, you can see the same. This is for Malathion. With Malathion, we did not see much of an improvement with the Combi Protect, but we see some improvement with Delegate, especially at the 4 days after treatment. You can see here at the half rate. So we also looked at the number of eggs, and this is for Imidan. You can see here at the half rate, we see a reduction in the number of eggs with the Combi Protect at the half rate, and also at the full rate, at least numerically. This is with Mustang Max, and some numerical reductions here and here, as you can see, not much here, and a little bit with the full rate. With Malathion, we did not see much of a benefit. With Delegate, we see some benefit at the half rate with addition of with the Combi Protect, and also at the full rate after 4 days. So these data are similar data collected from Georgia. Here also with the Imidan, again with the half rate, you can see an improvement. With the Combi Protect 3 days after treatment. Here, not much of an effect. Malathion also not much of an effect. here you also see with delegate an improvement 0 days after treatment with a half rate. And this is for the egg counts, not much of a difference with and without the Combi Protect. For Imidan or Mustang Max, this is for malathion. We did not see much of a difference. With delegate, you tend to see some numerical differences. So some thoughts. We know we are finding that so far that these attract and kill strategies show some promise in reducing Spotted wing Drosophila infestation, and this could lead to a reduction in insecticide use. However, we are finding that their efficacy can be influenced by different factors, such as the sex of the Spotted wing Drosophila. We see that they are differentially affected, whether they're males or females, also whether the females are mated or unmated. And also, it depends on the size of the population. These technologies tend to break down if the population of a Spotted wing Drosophila is too high, and also if you have too much fruit density. Also, like as I just mentioned, it can be influenced by the presence of fruit because they can outcompete these strategies. So right now we are going through the registration of ACTRA and Combi Protect, and I'll mention that a little bit later again. So one thing that we believe is that these strategies might work better when in combination, especially when you combine attract and kill strategies with repellents and deterrents in these push-pull systems. So the repellents and deterrents act as a push to push the Spotted wing Drosophila away from the crop, and these attract and kill strategies can serve as a pull to pull them into a place where you can kill them. So, we're looking, for this reason, we're looking into identifying novel repellents for Spotted wing Drosophila. And Greg Loeb's group at Cornell has been working on this repellent, 2-pentyl-furan. So they have conducted these cafeteria-style assays where they looked at different compounds, and they found that 2-pentyl-furan repels Spotted wing Drosophila. They have done some also field evaluations with this compound and found that it can reduce the number of eggs in the fruit. And also when placed in the field in these bags, they also found that at high rates, they can reduce the level of infestation per berry. So these are some of the outputs from our team on the behavioral control sub-objective. We have produced several articles, and we are also in the process of gathering all the data on Combi Protect for 2 years, and we're going to be working on at least two publications from that study that has been conducted in many different states. And as I mentioned, I want to finish with, I know that there's going to be questions about this, so I wanted to just mention that I'm working, we as a team are working with companies towards the registration of these products. We're working with ISCA Technologies and Undermat. ISCA Technologies produces ACTRA, and we're working with EPA right now with ISCA and EPA towards the registration of this product, and also I'm working with IR4 and Undermat to register Combi Protect across different states in the US. So that's all I have.
Thanks, Cesar, for a quick update on behavioral control. And I also wanted to mention that we did earlier, back in December, we did our annual webinar on behavioral control work that we have done over the years through this and other SCRI and OREI projects. So if you want, I will provide a link in the chat if you want to watch the webinar, which is available on YouTube and on our project website, which is swdmanagement.org. We still have some time. If there are any questions for Cesar or Kent, please, questions or comments, please let us know.
There are a number of questions in the chat.
All right, let me read those out. So Hannah had a question, Hannah Brock. Did you have a half rate of delegate by itself anywhere, Cesar?
We did not include the half rate in the first year, just because of limitations with the number of cages that we were using. And at that point, we just wanted to see whether it provided any benefit by just the addition of it. But in the second year, like last year, we did include the full factorial design with the half rate and the full rate with and without the Combi Protect. So we do have that. And we did see some benefits, as I showed. The company, one of the things that the company it's eager is for us to test it under a larger scale, like in commercial farms. But again, we're waiting for registration because they believe that these technologies are going to work better at larger scales, which makes sense. But again, with the product not being registered, we had limitations on that.
Thanks, Cesar. Next question is using a half rate of insecticide safe as far as resistance development is concerned?
So that's a good question. I even using the half rate, we were still within the label rate. So we are, we're using a rate that should provide control of the flies. We're just looking at whether by adding the Combi Protect, we're getting some additional benefit. So I don't think that we are, it's a rate that the one. I mean, that's something the company. Just this is a side note. The company the ultimate goal for the company is for us to use it as a bait, which is just using it in very small quantities, very small volume. Right now, we are just using it as a cover spray, just because of how the practicality. But the company wants us to test it as a bait, which will reduce the volume by a lot, like 90% of the volume that you're spraying and the amount of insecticide. Lab studies that we have conducted seems like to show that it works as a bait, but again, translating that into the fields is something different.
Just to explain how half rate means for these studies that we did, it was, on label, for example, delegate as 3 to 6 ounces per acre, right? And we considered full rate as the maximum label rate, and half rate was half of that, which was 3 ounces per acre. And that is also still on the label. So we are not off the label recommended rate for this particular product. But it may be an issue for other products where there is only one rate in that range.
Yeah, but so far, everything that we have done is within the label rate. So even if we reduce the rate, we're still within what the label says.
Perfect. Thanks, Cesar. Okay, so our next question is Combi Protect plus half rate less expensive than full rate?
That's I got that question at a growers meeting recently.
That's $1 million
That's
question.
a $1 million question because we don't know the cost. Yeah, the company hasn't disclosed the cost yet. So and yeah, that's something that definitely with Miguel, I'm sure, like, you know, this is a thing that we're going to have to work with Miguel on whether this is going to be economical for a grower. Is that benefit that they are getting, that, you know, percent benefit that they'll get with the Combi Protect, does that justify the cost? You know, so that's something that if it works as a bait, you know, that's going to be a big thing, because then you're not going to you're going to minimize a lot the amount of insecticide used. So that, to me, and that's I think why the company is pushing for that, because then it makes more sense for them. It would be more economical that way for a grower to use the Combi Protect and add a Combi Protect if they are just going to reduce the amount of volume that they are going to spray.
Just wanted to let everyone know that we do have Andermatt representatives on the call, or at least we invited them. They may be present, and during stakeholder comments time, we will also give them a minute or two to you know, make their comments and sort of update us where they stand on that. And at this point, we will all team members, especially behavioral control team, there are some more questions. Can you all please take a look and respond to the questions that are relevant to your expertise? And at this point, we will take 5 minutes break for everybody, just to stretch your legs, and then we will resume our meeting with the objective 4 update at 1 minute past 3 p.m. Eastern time.
Ash, also, Agenor and Andy are here from
Yes.
Eastern. Yes.
So they are part of the stakeholders. We'll give them opportunity to give quick updates as well. Thank you. So 5 minutes break. We'll resume 1 minute past 4 with the objective 4 update. Thank you. All right. Cool. Again, thank you all very much for joining. Let's go ahead and get started with our next item in the agenda, which is Objective 4, which is to assess and reduce the risk of insecticide resistance development in SWD. Objective leads are Joanna Cho from UC Davis and Rufus Isaacs from Michigan State University. And today the update is going to be led by Fatima Ganji-Safar. She's a postdoc in Frank Zalem's lab at UC Davis. And Christine Tablock, she's in member of Joanna Cho's lab at UC Davis. So they will both lead the update today. Fatma, you can go ahead and get started.
Sure, thank you, Ash. So yeah, I'm Fatima, and I'm reporting the work that was done by our team in 2020 for Objective 4 of the project. The first sub-objective was to monitor development and extent of insecticide resistance, and this is the work that was done in multiple states. 9 states did this monitoring in 2021, measured insecticide susceptibility of SWD, and last year also we did some monitoring in California, and also our colleagues in Washington did some monitoring. But we've been focused on other projects than monitoring as well, especially in California, that we detected resistant populations. We've been more focusing on understanding the stability of resistance in these resistant populations, and also exploring mechanisms of persistence. The technique we use for detecting resistance is called rapid test. It's been developed by our colleagues in Michigan State. It's a glass vial bioassay in which we treat these scintillation vials with discriminating dose of insecticides, and once they're dry, we add 10 SWD flies to vials, and after 6 or 8 hours, depending on the insecticides, we count the number of that. So this discriminating doses are based on LC.
You're not presenting, it's just on the first slide still.
Is it? Let me see.
I think you need to hit presenter.
So you're not seeing my slides?
It was still on the first one. Now we can see them. It just wasn't changing with when you were changing.
Oh. Okay, let me see.
It wasn't in presentation mode, that's all.
So are you seeing the slide showing rapid test now?
Yes. Yeah.
Okay. Okay. The discriminating doses were based on were determined based on LC 90 times 8 for a susceptible population from Michigan, and they had already been determined for 6 insecticides, which were Mustang Max, Meltine, Delegate, Entrust, Lennet, and Imidon. And last year, 4 new insecticides, Acel, Brigade, Downfall, and X-Rail were added to the list, and their discriminating doses were determined. So our colleagues in Washington did some resistance monitoring in 2021. They collected 3 populations from blueberry fields in northwestern Washington from 3 different sites. So the numbers on the map show the number of SWD females that the colonies were established with. So all these flies were 100% susceptible to the screen insecticides, which were Mustang Max, Meltine, Delegate, Entrust, Lennet, and Imidon. They also did monitoring in Washington in 2022. Two populations were collected, one from blueberries in Western Washington and one from cherries in Eastern Washington. The population collected from the west side was 100% susceptible, and screening of the east side population still going. Sorry. So in California, we had already detected that most of populations are resistant to insecticides, particularly to Mustang Max and Entrust. And we had 4 populations collected from strawberries in 2020 that we had done dose response bioassays with, and we know the exact levels of resistance compared to our wolf scale population, which is our susceptible control. And as you can see in the graph, these are the LC50 values for the populations. And also the graph on top shows those response curves for those populations compared to the red line, which is for our susceptible colony. We already noticed our resistance, so we wanted to know if there is any change in susceptibility if we stop exposing them to the insecticide. So we reared these populations in lab for 10 generations and did another dose response bioassay at generation 11 to investigate those changes. And as you can see, there is a decline in LC50 values or increase in susceptibility over time in most of the populations, the resistant levels just remained the same as in population 3. We did the same thing with Entrust. Again, you can see that there is a decline in LC50 values, increase in susceptibility in all populations. Although the change is not very significant for populations 3 and 4. And we're not sure what the reason is. It could be due to initial number of flies at the time we started these colonies with. For example, populations 1 and 2 started with more than thousands of flies, but populations 3 and 4, we started them with less than 100. So frequency of resistant individuals relative to susceptible ones in a population at the time of collection could explain these results. But we also, there are some other things, like we don't know the fitness of susceptible versus resistant flies. And that is something we need to investigate more to better understand the susceptibility, stability of resistance in these populations. But the important thing is here is that even though we see the decline in LC50 values, they're still the resistance levels are still high, and field rate, the maximum field rate cannot even kill 50% of the population. So to better understand resistance stability in populations in California, we collected new resistant populations from strawberries last fall. And we have been doing, this is the graph showing their susceptibility at the discriminating dose for Mustang Max and Entrust. Again, they show high levels of resistance, and And we have been doing dose response with these populations, and the goal is that we are going to do studies in which we gonna mix these populations with our susceptible flies at different ratios, and we're gonna see if there is going to be any change in susceptibility, and if that happens, how fast that happens based on the ratio that we're using for susceptible versus resistant flies. The other thing that we want to do is to split them into two different subpopulations and have a treated versus non-treated control, and then compare their susceptibility over time to better see the changes. So the message in here is that our monitoring indicates that flies in most regions still are highly susceptible to different insecticides, and most of the populations are still killed by field rates of insecticides, except in California. So far, resistance has been observed only in California to Entrust, Mustang Max Brigade, and Malathion. And implementing integrated resistance management is important to avoid other regions to reach levels of resistance that California is dealing with, which can be done through resistance monitoring, rotating different chemical classes, and continued adoption of IPM. With that, I switch it to Christine to talk about mechanisms of resistance.
Thank you, Fatima. Is it okay if I share my screen? That way I can control. Thank you.
Yeah. Mm-hmm.
Hi, everyone. My name is Christine Tapilock, and I am in Dr. Joanna Chu's lab here at UC Davis. And today I'll be talking to you about our work in looking at the molecular mechanisms of insecticide resistance in Suzuki eye. So as Fatima mentioned, we have detected insecticide resistance in California. However, it hasn't been detected in other states quite yet. So in a susceptible insect, the insecticide denoted by these blue crossbones is able to penetrate through the insect cuticle, allowing it to enter the insect tissue, where some metabolic enzymes can break down the insecticide, but it doesn't break down all of them. And then the remaining insecticide can then bind to its target protein, allowing the insect to die. However, in a resistant insect, one of the mechanisms that can help build resistance is something called penetration resistance. So in this particular case, the insect cuticle is much thicker, preventing the insecticide from actually penetrating through the insecticide. From penetrating through into the insect. Another known mechanism is metabolic resistance. In this particular case, there is an upregulation or overexpression of metabolic enzymes, allowing the insecticide to be broken down prior to it binding to its target protein. And then finally, there is target site resistance. In this particular case, the target protein binding site is mutated such that the insecticide can no longer bind, and at least one of these mechanisms can result in the insect survival. It is also possible that through our study, we can identify new mechanisms that have yet to be uncovered. So understanding these different insecticide resistance mechanisms will allow us to monitor resistance in places where resistance has yet to be detected, as well as improve the management of SWD. So if we were to identify any of these mechanisms, we can develop a diagnostic for early detection. And then if we were to identify, say, specifically penetration resistance, we can suggest to growers to actually use baits such that the insecticide is being ingested versus just going through the insect cuticle, allowing the insecticide to be more effective. In the case of metabolic resistance, we can actually apply synergists in combination with the insecticide. Synergists are metabolic enzyme inhibitors, such that the insecticide could actually be broken down. And then finally, if we see target site resistance, we can adjust the management program such that we alleviate the stress and pressures of this particular insecticide. So the mutation conferring this target site resistance will actually go away. And then if there are any sort of new mechanisms, we can develop new technologies to counter said resistance. So in order to identify these mechanisms, we first want to identify resistant and susceptible populations of Drosophila suzuki'i, and then from that, develop iso female lines from the resistant population. So these are all lines generated from a single female, and the allele that is responsible for contributing to the resistance will actually be fixed within the population. So we'll have a susceptible and a resistant population. So far we have looked at lines resistant to spinosad, pyrethroids, and organophosphates, but in the interest of time, I'll only be sharing our results from spinosad and pyrethroids. So, excuse me, once we've identified these lines, we'll extract RNA from these flies and then prepare them from sequencing. We'll sequence the RNA on 2 different platforms, on the conventional Illumina short read platform, as well as the PacBio long read platform. And I will get into this in a little bit more detail later. And then once we have the sequencing data, we perform bioinformatic analyses to identify these insecticide resistance mechanisms. So how exactly do we identify these resistant and susceptible lines? So as Fatima mentioned previously, we do the rapid bioassay technique in order to identify the populations. Here, we tested 8 different iso lines from a caneberry field in California, labeled C1 through C8. And then as a control, we use the wolf-skill population. So these flies came from an orchard that is unsprayed and is known to be susceptible. And then on the y-axis, we have the % mortality. So you could see, as compared to the wolf-skill control, the line C3 and C4 have a significantly lower percentage of mortality, suggesting that they are in fact resistant. So these are the 2 lines, resistant lines, that we are going to use for sequencing. And then as a susceptible control, we're using line C7 and C8. So because all of these lines are from the same population, they're more genetically similar to each other. So we chose to use these lines as the susceptible control, so we can associate any changes we see at the gene expression level to be the result of resistance and not necessarily just biological differences between the populations. Okay. So in our RNA-seq data from the lines that are resistant to spinosad, what we saw is that in one of the lines, C3, there is an overexpression in the amount of cuticular genes as well as tweedle genes that are listed here below, suggesting that there is penetration resistance, but we don't see that increase in the C4 line. What we do see in the C4 line is an upregulation of genes involved in metabolic resistance. So these include those in the cytochrome P450 class, heat shock proteins, as well as GSTs. So this suggested to us that one line is resistant to spinosad through penetration resistance, while the other line is resistant through metabolic resistance. So we also performed functional analysis to see what the enrichment categories are, or which pathways these upregulated genes are enriched in. And in the C3 line, we see many of the enrichment categories to be chitin-based or cuticle, again, further supporting that there is penetration resistance in this line. And then in the other line, we see more of an upregulation in the metabolic pathway as well as carbon metabolism, suggesting that there is, in fact, metabolic resistance happening in the C4 line. So to take this a step further, what we decided to do is to take a couple of these genes and see whether they are upregulated in a current population of Suzuki-I. So the previous data I showed you are from lines from 2019, and then this particular data is coming from 2022. So I picked 3 genes that suggest metabolic resistance, which are the 3 up here at the top, and then 2 that suggest penetration resistance, which are here at the bottom. And the way to read this graph is we have the expression levels relative to the susceptible population on the y-axis, and then on the x-axis, we have our 2019 susceptible and resistant populations, and then the new 2022 populations are here in gray, lines 1 and lines 2. So you could see that for cytochrome P450-6A8, there is a significantly higher amount of this gene being expressed, 300-fold, as compared to the resistant population. So not only are we seeing an increase relative to the susceptible population, but we're seeing it to be much higher than it was 3 years ago. Same is true for the cytochrome 6014. So it's 2-fold higher. And in the CYP6W1, it's 1,500-fold higher in the new population as compared to the old 2019 populations. So this suggests to us that we see a persistence of the metabolic resistance in the new populations. And we also looked at penetration resistance, and you can see in these 2 lines, there is no significant difference in the amount as compared to the susceptible populations. So we don't see any evidence of the penetration resistance continuously propagating in the populations. So the 2022 population show an evidence of enhanced metabolic resistance. And this suggests to us that the new populations are actually also more resistant. And Fatima is currently in the process of performing dose response assays to determine whether this is true. So we can actually use a combination of these genes to monitor resistance over time. So the next thing we did is we looked at target site resistance. However, we didn't see any mutations suggesting that there are mutations in the target site. But we do know that the target protein of spinosad insecticides actually have different splice variants, and these variants confer resistance. So splicing is a natural process by which regions are removed from a mature mRNA molecule. So that's these intronic regions denoted here. And so splicing is a way to make different proteins of various functions from a single gene. So it's possible to get, say, one isoform where you have exons 1, 3, and 4, and then in another isoform have exons 1, 2, 3, and 4. So D-alpha-6, the target of spinosad, contains 12 different exons, and it has 2 regions that have mutually exclusive exons, meaning you can only have either A or B, but you can't have both. So this exon 3 is what contains the acetylcholine binding domain, as well as the domain where the insecticide binds. And in other species of insects, for example, Tuta absoluta, what they found is that without exon 3, these insects now become resistant to insecticides. So we wanted to see whether we can find anything like this in our data set using our long read sequencing data. So our long read sequencing data revealed that there were changes in alternative splicing in our resistant populations. So we saw that in the susceptible populations, say isoform 1 is more predominant, whereas in the resistant populations, isoform 2 is more predominant. And one of these genes is a cytochrome P450 gene. So as you can see here in panel B, there is this region of DNA, this insertion, that is only present in the resistant populations and is not present in the susceptible populations. And this particular region is located in the 3' UTR of the gene. So it's not in the gene body, it doesn't have a mutation in the protein coding region, but this particular 3' UTR is important for RNA stability and protein translation. So we think that this particular insertion might allow this gene to make more protein. So if you have more protein, you can break down the insecticide more effectively. So we see this to be very widespread, and it's not just genes that are related to insecticide resistance. So there's possibly a stress response happening in these insects that's causing the splicing changes. So finally, we detected evidence of 4 different mechanisms of insecticide resistance. In our spinosad lines, we see penetration resistance in line C3, metabolic resistance in only line C4, and then no evidence of target site resistance in either. And then we do see changes in splicing in both lines. And then very briefly in our pyrethroid data set, we don't see any evidence of penetration resistance, but we do see evidence of metabolic resistance. And we see evidence of target site resistance. In this particular case, we see less of the target protein being expressed as compared to just having a mutation in the target site. And then finally, we also see changes in splicing. Are there any questions?
Any questions related to objective 4, resistance management? If not, let's move on to the next objective, which is objective 5, and that is to develop and disseminate actionable recommendations that enable producers to optimize pest management decisions and evaluate their impact. That is led by Dr. Kay Kelsey from University of Florida and myself at University of Georgia. I'll invite at this point, Dr. Kay Kelsey and her team to update us on evaluation efforts of the project.
Well, thank you very much, Ash. We appreciate it. And thank you all for participating today. As part of our evaluation study, we're actually evaluating this workshop as well. We have a Qualtrics survey that I'll go ahead and cut and paste in the chat. If you'd like to fill that out either today or tomorrow, that would be great. We're trying to figure out whether or not this project is meaningful to you. And so over the past couple of years, we've collected a lot of data. We do have a slideshow to share and summarize some of that data with you. If Sarah could pull that slideshow up, or Dami, if you have it handy, or Sarah.
Yes, I have it handy.
Okay, great. Thank you. So Damilola Ajay is a PhD student working with me. He's getting a PhD in agricultural education and communication, and he is becoming an evaluation specialist. He comes to us from Nigeria, where he practiced evaluation for about 10 years before coming to the United States to study a PhD in evaluation. So he's doing a great job of collecting and analyzing data, and he will go ahead and share what he's found.
Thank you so much. I want to share my screen. Do I have the permission? Okay. Can you see my screen?
Yes, we
Okay,
can.
great. Thank you. Okay. Thank you so much. Good afternoon to everyone. Specifically as regards our activity as an evaluation team, we tried as much as possible to capture all the outputs and the outcomes from those research activities so as to measure the impact that this research work, this collaborative research work has actually had on the lives of our participants, on the operations on the field, as well as provide an opportunity for us to actually assess even the accomplishments vis-a-vis the deliverables that were promised by the researchers involved in these activities. Strategically, these activity enabled us to understand the experiences of our stakeholders on the field, the challenges that they had while utilizing some of these technologies that were developed by this unit, and also the needs, what they feel that would be needed for them to actually make a significant progress in their activities. It also provided us the opportunity to actually celebrate the team's wins and also to identify our weaknesses so that we can know the specific areas that needs improvement, and as well as provide justification for us to for accountability as for the investment of government funds in this project. And finally, what we're doing is to assess what growers have actually benefited from this research effort and how it has actually impacted and translated to profits on their farms, and how it has influenced their production activities, and specifically how the socioeconomic impact has actually been generated, and how the project has enhanced the productivity of green crops, while dealing with these invasive pests. Okay, during the course of our activities last year, we were able to engage in all the activities that were carried out by the unit. We attended all the meetings. We collected different information from different sources. And at this point, I would like to appreciate all our stakeholders that visited with us last year and honored our invitation to participate in our interviews. They were really germane to the activities that we did, and they provided a great amount of insight for us to actually know what their lived experiences are on the farm utilizing all these technologies. So last year we engaged a grower baseline survey, which were used to track information as regards the knowledge gained over the years and how the knowledge of our growers have actually improved. And the interviews as well gave us an in-depth understanding of the realities, on the farm based on their daily activities. Okay, from our interaction with the growers, we discovered that looking at the level of concern and the need for SWD control management from the grower side, we discovered that 62.2% of them and 27.9% of them actually showed a substantial level of agreement with that they are really concerned about SWD on their farms, while 90.9% actually needed solutions to that. And it's going to be interesting actually that you have some set of people that never thought it was actually of any concern to them. Of course, the reality is across the US is actually different. And so this could be one of the reasons accountable for that, because people believe that it may not be present on their farm. So why should I care? And why do I need a solution about it? Anyway, that amount of people is actually negligible compared to the number of people that actually needs solution to this space. So that shows the reality on ground. And based on our qualitative findings, we discovered that 92% of our target audience were able to actually identify the practices to reduce SWD infestation on their farms. They were able to identify those control measures that they can actually implement on their farms just to cut down the activities of SWD. 85.7% of them were able to affirm that a pruning of berry bushes actually could actually reduce SWD on their farm. And these were knowledge that was not available 10, 15 years ago, but now we could actually determine the impact and the impact of the project on when it comes to the knowledge base of growers. And furthermore, 85% of them reported that the multiple suspension tactics which include actually the cultural control and insecticides called control SWDs. So looking at the various indicators that we use to actually check for knowledge gained that our growers might have actually had over the years, the result actually showed us that there's been progressive increase in the knowledge that our growers have actually gained and other stakeholders involved in this project as well. Furthermore, it's 1.3% of them reported that the naturally occurring biocontrol parasitic grafts, in the US was not effective in controlling SWD. And I know Dr. Kent actually made part of the presentations that was done earlier on. Some of these, I believe, not only Dr. Kent, but all the objectives that I've actually presented, some of the results actually corroborated with what we have, we are presented at this point in time. And it shows that the growers are actually telling what is affecting them on the ground or on the field, their experiences, as well as those experiences are matching with what our other researchers are actually finding, even on their own field, working on their own trial fields and experimental fields, and also on growers' farms. So the result is in tandem with what the growers are actually giving us feedback, and all other stakeholders involved in this process, in this project. From our qualitative study, we were able to interview about 26 participants last year, and these comprised of the growers and commodity group representatives, the researchers, the helicarial researchers on the team, the USDA scientists and extension agents, and the IT specialists. And this gave us an overall and holistic view as regards what's actually happening in the state of the field in the different states of the country, and we were able to gain regional insights to what is obtainable, and at the same time the peculiar challenges, of people, of growers, of states, of researchers, of these categories of people, working on this project. From the qualitative study that we had, we discovered that growers are really motivated to join the team because they had a significant problem with SWD, and I think this really tallied and corroborates the finding that we have on the quantitative side that shows that about 94% of them agreed, that showed a level of agreement that there was SWD was of significant concern to them. Some of these growers are still in denial of having SWD on the farm. This statement was actually made by one of our esteemed growers who actually said some of the growers, that was the statement she made. So that really agreed with, showed a lot of consonance also with what we had in our quantitative result. The stakeholders, including the growers, actually valued their roles as members of SWD team, as it gave them the opportunity to collaborate and co-create knowledge, as they try to provide solutions to these menace. And one interesting thing is that the project might look small and we think it's just within the US, but it's so interesting that some of our growers are actually disseminating this information even beyond the borders of the US, as most of these technologies now, some of the technology is being used in Mexico, in Canada, and some parts of Asia and Africa, which is such an interesting thing to actually know. And part of the technologies implemented by our growers on the field actually include the sticky red traps, the wet traps, the decoy, saltwater flotation, and all these evidences were actually as listed as on the screen. And I think most of the researchers too that I've actually presented earlier made references to all these specific control practices, and I believe it's really interesting knowing that their findings and what we are finding on the fields are actually in tandem. Then the challenges identified from our interactions with our stakeholders actually include the environmental and climatic conditions, which actually influence the effectiveness of the technologies on the field. And I think this was actually touched on by our researchers as well. The variation in the population dynamics of SWD, the high cost of the labor shortage, which really impacts the cultural aspect of it, which has to do with maybe hand picking and the early harvesting of the fruit, as well as the cost of labor and also the high cost of insecticides. And as regards from the perspective of the early career scholars involved in this project, they were able to actually benefit from this project through mentorship, through interaction with growers, having practical understanding and knowledge of operations on the field, and they were able to actually build their networking and social capital as well as developing their leadership skills, and that they've been able to collaborate on different projects to even come up with papers and journals, which is one of the most referenced indicators of progress in academia. And the scientists were able to actually advance their knowledge in SWD management, as well as discover new research approaches that can be explored in SWD management. These have actually enhanced their collegiality and also their collaborations with each other. And talking about the extension professionals too, they were able to actually have access to immense and beneficial information, which they actually use in their extension meetings across the states. So recommendation from going forward from our participants and our esteemed stakeholders include having an information dissemination strategy that will incorporate local communiques in different regions in such a way that information that are available in the West Coast should be made readily available to extension agents in the East Coast in such a way that they can actually digest those information and be able to apply it to their own environment and be aware of what is actually happening in other regions. And then there was this recommendation of having a group theme or Slack, which has to do with a content management software or technology that can help centralize the information for growers for researchers to access, as well as growers through their contact researchers. Then there is need for economic team as well as the evaluation team to have a kind of access to the regional meetings that are being held by all our participants, by all our participating researchers in the regions, because this is going to help us to actually capture relevant data for economic activities as well as the evaluation works as well. And communications with growers should actually be improved, and this should be done more through phone calls, texts, and maybe sometimes emails, because our growers actually prefer it, keeping it simple. They prefer it simple. And there needs to be constant update of SWD management website, as this is very essential for even for stakeholders that are both growers and even people that are not within the US. So people access this website beyond the walls and borders of the United States. So there needs to be a constant update of the website, and further research on improving the effectiveness of the product so that it can be used under different geographical and climatic conditions too, as some of the things that our growers are actually watching out for. And that takes us to the plan for the year 2023, which is this year. This year we're trying to embark on, we'll be embarking on specific interviews to actually track some progresses, and this is actually focused on some selected laboratories that we couldn't touch last year. So we'll be reaching out to them during the course of the year to get some information from them. And our second plan for this year is to have a kind of a national survey, a national impact survey, because between 2008 and now we have 15 years in interval, and we believe that the series of projects that have actually taken place should have produced some reasonable amount of impact in the production process within the agricultural space. So we will be conducting a national impact survey, and we'll be engaging and soliciting for the help of all stakeholders to help us with the administration of that survey. And this is going to be going through the Growers Association, listed in all the states that are participating in this research, and even states that are not participants. So it's going to enable us to actually track the impact of this project on operations of growers. And specifically, it's going to be, we're going to be working on all the berry and cherry growers across the United States that will be going to be leveraging on the peers and co-peers support through the Growers Association to administer this survey. And data collection is going to be done via Qualtrics, and it's not going to be more than 20 minutes long. So we hope to have this done this year, so that as we advance, as we collectively advance the research frontiers of SCRI project. Thank you. So if there's any questions, I would like to take them.
Any questions for the evaluation team at this point? If not, let's move on to the second part of Objective 5, which is extension and outreach. I'll give you a very quick update, intro and update of the project team and efforts that we have done last year. And then we will move on to our stakeholder summaries section. And do you see my screen here? Basically, this project, as you see here, is moving from crisis response to long-term integrated management of SWD, keystone pest of fruit crops in the United States. It was funded in 2020 and goes till 2024. Excuse me. Here is the long-term goal of the project is to develop and deliver systems-based integrated management programs to berry and cherry growers that are cost-effective and environmentally sustainable for long-term management of SWD in the US. And this is our team from multiple institutions, starting from UGA to University of Florida, North Carolina State University, Oregon State, Michigan State, UC Davis, UC Berkeley, Cornell, Rutgers University, University of Maine, Washington State University, and USDA ARS. We have a large team of researchers with extensive experience in working with the multiple aspects of SWD management. And objectives, as you have already gotten updates on Objective 1, which is implementation of pest management practices. Objective 2 is developing economics-based decision aid tools. You already got update on that. Objective 3 is evaluating sustainable alternatives to long-term management of SWD. Again, you got updates on biological control and behavioral control. 4 is resistance management, which you all also got an update on that. And Objective 5, which is evaluation and extension. So we have done a lot of work to disseminate information from all of our team members to stakeholder meetings, websites, webinar. We also did our annual webinar back on December 8th. This is a wrong slide. A date for that is actually, it was delivered on December 8th, 2022. And it was on behavioral control of SWD. You already got an update on that one as well. So our plan is for next year. Here is actually a list of our stakeholder advisory board members. Since we have developed this list, we have there have been some changes in the advisory board members. We did add some new members, and in this advisory board. So, for this past year, we have, as I mentioned earlier, here is the actual correct update and link to our webinar that was delivered on December 8th. It was delivered on December 8th. We had about 300 people registered to join the webinar. And since then, we have posted it on our project website, which you can see the link here is www.swdmanagement.org. Most of our or all of our project updates are posted there. And for next year, we are planning to do a webinar on updating our efforts on biological control of SWD. As you heard from Kent Stock, we have, as this team has started working on biological control ever since the beginnings of SWD in the US. It took several years to get to actually receiving the permits to now we are at a point where we can do some releases, and as you got some updates from them already, work is ongoing. With this, I will open the floor for any questions you may have at this point for any of the objectives. You can ask questions, everything that has been presented thus far, and then we will get into our stakeholder summaries segment, which is up next. I just want to remind you that Hannah shared this Padlet link. If you have time, please do take a moment to fill that out based on your experiences. That information will help us all plan our next steps in the project. And also, evaluation team is looking for feedback related to this project. And Kay also shared that link in the chat. If you can, please do fill out the survey as well. Any questions, comments, suggestions? All right, if not, let's move on to stakeholder summaries. And I'm glad we are moving right along. We are a couple of minutes ahead of the agenda, which is always good. And so let's start with the experiences of our stakeholders. I will basically call the names of stakeholders as they show up on my screen. And if you can briefly share your experiences at this point, this past year with SWD, how it was in your systems that you work with or your farm, and how you managed it, and what your thoughts are based on that. So I'll stop sharing this, and I will share at this point the meeting agenda. And I will, so at this point, I'll call maybe, give 1 second. Albert Wiles from Georgia Blueberries. Are you still with us?
Yes, can you hear me?
Perfect. Yes, we can.
The 2022 season was like it has been the last couple of years. SWD was not a major problem. Thanks to the research that you fellows have done, you've got some really good spray programs out here, and been able to communicate with the growers and with extension that when we begin to see blue fruit, and I've said this more times than one, we do a good job of hitting it pretty hard early in the season. And fortunately, the weather has cooperated to the point that it has not been a major problem. However, the spray programs is just a Band-Aid, and we know that because, like you said, biological control has been the goal of this team or whatever since the beginning. And I'm really excited to hear about the parasitoids and all these other things that are coming about, because with the spray programs, it brings on a lot of other problems. I look at the picture behind you, Dr. Ash, and that looks like a bud mites. Been in that bud there. We didn't have much problem with bud mites a few years ago. Perhaps the spray program has brought that on. We know it's brought on a lot of scale and other things, because we've knocked down so many beneficial insects, and we've got to keep using this Band-Aid. But at the same time, I'm really excited that the research is continuing to move into a biological control era.
Alrighty. Thanks, Albert. Appreciate your update. David Epstein is next. If you can give us a Dave update from Washington.
Ash, I'm a little bit divorced from day-to-day management of spotted wing in the new job I'm in here. So there are the folks here in Washington I know are on the call. Maybe Gwen Hoheisel or Tobin would be able to give you what the results are from this area. I'm just not in a position to do it right now.
Gwen, would you mind giving us an update?
Okay. Yeah, I'm unmuted. No, I'm unmuted. I just didn't know I could because I was on the difference. Yeah, I thought I was a participant, so I didn't know we could mute and unmute. So unfortunately, I wasn't around last summer because I was in Europe. So I have not done a good survey of where growers or how it was last season when it was cooler. So now that I'm formally back, I can go do some of that. But Ash, I'm not a good judge of how bad the SWD population was last year.
Why don't you go to Tobin with that, Ash?
Yeah. I mean, Tobin was out doing it with Extende and he probably has numbers. We were doing lab work, waiting to work with Bond to do another decoy trial maybe this year. So.
All righty, so let's move on.
Ash, I can talk if you want.
Yes, briefly.
Yeah, sure. So one of the main, in Eastern Washington at least, one of the biggest issues is that the spotted wing numbers build up, but most of the time, at least particularly for cherries, the cherries are harvested before the numbers really build up. And so we kind of avoid damage through the phenology. But there are some later season varieties that do get hit. But the biggest issue is that it's disrupted some of the Western cherry fruit fly programs. That they're instead of using something just for that, they're using more broad spectrum stuff.
All right, thanks, Tobin. Hillary Thomas. Hillary, can you give us an update on SWD situation in California and other stakeholders that you work with? Do you have Hillary? Hillary, can you hear me? No, okay. Let's Jimmy click. Jimmy, can you hear me? Lots of names are showing up as Sarah Jones, so that has been an interesting challenge. All right, so let's move on to Dale. Dale, can you hear me?
Yep, I just got unmuted. So here in upstate New York, New England border area, 2022 seems like a long time ago, and I don't really remember much of it. But in general, my recollection was that spotted wing populations were fairly low later in the season than what we normally expect them to be. But then when we started to get some more humid weather, populations really took off, which is not too surprising. On my own farm, we now have had 4 years of 0% infestation under a netting system. And over 9 years now, we've had less than 0.5% infestation over 9 years in blueberries. So I don't really worry about it as a pest anymore. I know what I need to do. Our raspberry tunnel, we're still getting less than 2% infestation in fall raspberries. And I had some problems in the past with indoor strawberries, tunnel strawberries. And now that I've put netting on the tunnels that I'm growing strawberries in, I'm not having any problems with it in strawberries either. So it's becoming a pest that I don't really worry about anymore. There are more people putting up netting systems that have been very impressed with the results that they've been getting. So I think for small scale growers, the word is starting to spread that this is a really effective way to keep spotted wing out, and we'll see how much more it continues to grow. I think the thing that I've been noticing the most is that there's a lot of area for research in the horticultural aspects as far as what's happening under that netting, because the yields that I'm getting under netting are just absolutely phenomenal. Some things that I'm seeing as far as plant growth goes are, I think, probably due to the netting, but we're not sure whether it's a light issue, it's a shade issue, it's a light diffusion issue, it's a reduction of wind, or what's going on. But from our perspective, we need some more horticulturalists involved to start looking at some of these other questions, because we don't have to worry about spotted wing anymore.
Thanks, Dale. Let's move on to Nate Nose. Nate.
Good afternoon. Can you guys hear me?
Yeah, yes.
Can you hear me now?
Yes, we can.
Okay, thank you. Sir, I'm having a little technical difficulty. This year, one of the hottest and driest on record in the Northeast. And because of that, I agree 100% with Dale. We saw much reduced populations, and it didn't build until we got some rains later in August and September. For the most part, we've been looking at the season and the pruning effects. And I'm a big believer that pruning and other cultural practices can make a big difference. We saw it here for forever. Now that we're gathering the cull fruit 100%, it's really helped reduce a lot of that. When growers talk about going to 1-day pick, it really works. And I know organic growers that are getting very little problem or very little infestation when they're picking every day. When we look at the numbers, everyone says, well, you're spending all that labor and time. What we're seeing is the time spent is only about 10% more than what you would think, and the yield has been higher because we're putting less culls in the bucket. So there's an offset there. It isn't 100%, but it's at least 50. The other thing we're looking at really hard is that as we get into wetter conditions, that we know that we're going to be multiple days of rain, or we're using a sail as a way to help prevent larvae from hatching, or eggs from hatching, and killing the larvae before they get too big. We're doing that in the fall for sure. There's a 3-week window, 4-week window from August to September. And then once things get down below 70 degrees and it's not so wet, we can manage that pretty well without it. But there's that time, and then there's a week or two in July, early August, we might do it on the summer fruit. As far as other things that I've seen is that a lot of people are planting raspberries again, and they feel that they can manage it for the most part. The U-pick is is not making as strong a comeback, but it's coming back. I appreciate being on, and thank you for doing this.
Thanks, Nate. Appreciate it. Do we have anybody from AgriCare in Oregon? I know we had a representative on the call. Do we still have somebody from AgriCare on the call? No, I guess not. Do we have somebody from Maine? From Maine. I know we had a representative from Maine in the call earlier.
I think we've lost Eric. He had to go pick up his kids, unfortunately.
All right.
I can echo what we saw here in Maine this year, if that would be helpful, Ash, but
yes,
not,
please.
you can move on.
Sure. You can update us on the situation there.
I'll just echo, I think, what a lot of people have said already, that here in the Northeast, we had really reduced populations because of the warm, dry weather this year. But I will say, we got some feedback from some of our growers at our advisory board meeting last week, where multiple of our larger growers are sticking with just doing perimeter sprays based on some of the recommendations we developed as part of this project. So it's a good change in practice, and they seem to be very happy with the results they're getting with just spraying the border. So.
All right. Thanks, Phil. At this time, my screen, where I see the people list of attendees, I'm seeing most of the attendees with name Sarah. So I'll just have to do open call. If any of the stakeholders that have not given us an update so far, if you are still on the call, please unmute yourself and give us a quick update. Again, nothing detailed, but a short and sweet update.
Hey, Ash, it's Tracy Lesky. How are you?
Doing well. How are you, Tracy?
Good. So I don't really have much to add to what's already been discussed as far as SWD pressure, but I would say from the standpoint of just following an invasive species project, seeing the progress that you all have made on, really drilling down toward decision trees and the insectary system for biocontrol, as well as the behavioral control and the potential for some new registrations and things like that. I think it's great, and I just want to commend all of you for a job well done.
Thanks, Tracy. Appreciate it. Do you have any other advisory board members that would like to provide summary, updates, share their experiences with SWD?
Ash, Letty's not here, but I can just quickly say something. It's been a really hot, dry season this last year in Oregon. We've been trying to do some monitoring, not been able to find any real infestation to talk about. We're very, very excited about biocontrol. I know Jana is also here. There's been some tremendous progress done with the biocontrol, so we're looking forward to dealing with spotted wing this year as well.
Any other comments from other stakeholder advisory board members that are on the call?
I could give a quick update from what I've seen in North Carolina, since I think our members dropped off. So it's really cool to hear everyone else saying they have very low spotted wing levels. In North Carolina blackberries, it's very different for us. We get very high infestation levels still. In the early spring, levels are pretty low, but as soon as July hits, we tend to get weeks after weeks of rain, and then the populations almost every year get entirely out of control. Some growers, when it gets to that point, they just cut back their canes and end their harvest. And so we're really looking forward to developing these decision trees a little bit more to hopefully help fine tune some management plans and trying to account for weather. So still working.
Thanks, Hannah. That was a good update. Do we still have Ben Cantrell on the call? Ben from Michigan Blueberries? I guess not. So any last call on any other stakeholder board members that have not given us update yet? Would appreciate if you can unmute yourself and give a quick update. If not, we have a special group of people invited from United Kingdom. They are developing a new idea and wanted to share their thoughts and plans with us. It's a new company, Biocentis, and I will hand this over to you guys to present your plans and the area that you would like to help SWD control. You can share your slides. I'll stop sharing.
Thank you very much, Ash. Here, let me see if I can share this. Okay, can you see that fine?
I was thinking. Yes.
Okay. Excellent. So I'll try to be quick. I don't want to take up everybody's time. I'm from Biocentis, and we are developing more effective genetic control methods for spotted wing Drosophila. And it's a real pleasure to be here today, and thank you all for giving us some time to talk through our potential solution. So who's with us today? So we have a small delegation. We have myself and Joanna Morianu. We're both scientists. I helped develop the technology a number of years ago, and Joanna is now the project lead for Drosophila suzukii. And we have Georgia Rocca, the CEO, and Federico Guelpa, the head of strategy, both of whom come from a consultancy background. So today, I'd like to introduce you to our technology platform and present a high-level development and testing plan for our genetic control solution for Drosophila suzukii, and have a few minutes for questions at the end, should you have any. So I think you are probably most of you very well aware of the sterile insect technique, and it's now a sort of traditional technology that can be used to control a number of different insect pests. The idea is simply that you rear a huge number of insects in a contained setting. You remove the females and you're left with just males. You sterilize those males and you release them into the wild. And if those males mate with females at great enough number, then you effectively sterilize those females in the wild, and it results in a reduction in the total number of those insects. And the technique is actually quite important because it's non-toxic, it's environmentally friendly, and it's been used with great success for a number of insect species, but has been very difficult to extend to others, such as Drosophila. And the reason is it's actually incredibly expensive to rear these insects at a scale that would be needed for it to be effective. And people have worked on other versions of it using bacteria, gene editing, and alternating types of irradiation to varying degrees of success. So there's an idea that we've been very excited about, and it's what I spent the last decade working on, and it's something called gene drive. And it's the idea that perhaps we can use the insects to do the work for us rather than having to release them in such huge numbers. So if we made a mutation that is somehow useful, then that mutation gets inherited by half of the offspring, but not the other half. And that would be a standard gene or a standard mutation that you could create in the lab, but also just those that exist in the wild. And if you were to release these insects, then that mutation, which is the sort of red insect you see on the right, that would tend to disappear over time, or at least stay at the same frequency that you release it. What a gene drive does is it bends the rules of inheritance. It changes what happens in normal normal natural reproduction, and it allows a gene to spread through an entire population very, very quickly. And it does that by biasing its own inheritance. So this special gene called a gene drive can be inherited by all of the offspring instead of by half. And so it doubles and doubles and doubles in a population. And we can use that to do something very interesting. We can add a trait that makes those insects die. And that means that you can suppress the population. So you release a small number of insects. Those insects spread a mutation throughout the population. They spread and spread and spread. And as they do so, the population starts to crash. So it's potentially very exciting, very powerful, and potentially very cost effective. So the idea was developed in 2003. And in between that time, I started working on the project. And between 2011 and 2016, we managed to get this technology working using something called CRISPR, which is a gene editing tool. And we got that working for the first time in 2016. It was the first time a gene drive had been shown to work, in this case, in the malaria mosquito. And as we heard from Christine and Fatima earlier, you can have problems of resistance. And you can have problems of resistance with insecticides, but you can have resistance to any technology. Insects are going to find a way to overcome them. And we saw that happen with the first iterations of this technology. But by 2018, we developed a version which has never failed. And there are important biological reasons why it's able to evade resistance and stop those insects from adapting. And in 2020, we had seen that the project had done very, very well for the malaria mosquito. And that has remained part of what's called the Target Malaria Project. But we saw that this technology could be adapted for other problems in the world. So we actually span out a company called Biocentis. And that's now where I'm based. And we are trying to use that technology to control the spotted wing Drosophila. So just to give an overview, this is a technology which has gained quite a bit of excitement in the world. We've had a number of high impact publications in Nature Biotechnology and Nature Communications that showed, one, the first gene drive ever that worked, and then a gene drive that was able to eliminate entire populations of the malaria mosquito. We showed a technology that's able to reverse it. And finally, we showed that you can actually release these insects in an environment that mimics Africa. So sort of like what you might imagine with greenhouse experiments, but in this case for the malaria mosquito. And the technology worked incredibly well, even in the environment that mimics nature. And just to give a very brief overview of the sort of most stunning result that we saw, these two cages, they show two important things. On the top, it shows that you release your insects into a population just once, and the insects do all the work for you, and they spread. So we release them at 20% frequency, and they spread to the entire population in less than 6 to 8 months. And below that, we looked at how well that population could reproduce. So we counted how many eggs the entire population was able to make. And initially it started at 30,000. And within a few generations, they were unable to reproduce at all. So we completely eliminated insect populations using a single release of our mosquitoes into a larger mosquito population. So it's the first and only time anything like this has been done. And we've since managed to do it several times with different versions of the same technology, but no other group has achieved the same thing. So what do we envision? Well, we think that the technology that we described before, which is this, we call it a self-sustaining gene drive, is not the right tool for all of the insects in the world, because it's something that can spread potentially to an entire species, and that's probably not the right thing to do for the vast majority of insects that cause a problem. So for something like spotted wing Drosophila, we thought, what if you can use a version of this technology which has been adapted to work only for a limited amount of time and only over a limited space? So this is our technology. It's something where you release them at relatively low numbers. It spreads for a few generations and then starts to disappear. But during that time, it's very effective. And if you want the technology to last longer, you just release more insects. So how does it compare with something like the sterile insect technique? So we've done mathematical models, and we think that compared to the sterile insect technique or some of the more modern improvements like Riddle or PGSIT or IIT, we think there's around a 30 to 100 times improvement over the number of insects you need to release for it to be effective. So it's potentially a very substantial improvement. But where are we? So we do not have a product, and it's going to be many years before we actually have something that we think is relevant to growers and people who need something like this now. But what we are doing is we are developing our technology. It will be about 3 or 4 years in the lab. But in order to do that, we need to understand the nature of the problem. We need to understand what is the biology of the insect in the fields where it's causing a problem. We need to understand to what extent they need to be suppressed, over what sort of time frame and what sort of area. So we need to engage with regulators and stakeholders to identify not only how to use the product, but what the product should look like and what the appropriate pathway is to trials. So we need data. We need to perform semi-field tests. We need to perform baselining experiments in the situations, in the sites where there is a problem, and understand what was the problem before we use our technology. And when we get to doing a field trial, what is the result of that after we use it? Because we want to obtain strong science showing that there is an effect of our technology and that the effect is strong and sustainable and economically viable. And we think that after about 3 to 4 years of laboratory development, where during this time we want to engage with regulators and stakeholders towards a field trial, we'll be ready to perform field trials in about 5 or 6 years. And during this time, we will be working not only with regulators, but also looking towards large-scale implementation and commercial use of the technology across a wider region. So I hope that was not too long, and happy to take questions. I'll also say if anybody does have questions they'd prefer to do offline, feel free to contact us on our emails. So myself, andrew.hammond@bioscientist.com, Georgia Roca, Federico Guelpa, Ioana Morianu, we're all more than happy to take questions. If you're interested in collaborating, knowing more about our technology, or teaching us things that you think we might need to know to make a better product.
So yes, floor is open for any questions from board members or team members or anybody. So please feel free to ask any questions you may have. So one, I guess, question or a comment I can make is that, you know, this technology seems really exciting and set up a step forward to where we stand right now for SWD management. What are the ways that you think we can help as researchers, or how you think can stakeholders help you move this thing forward?
Sure.
Do you have any sort of ways that we can help to make sure this technology actually this dream comes to fruition?
Yeah, I can imagine a number of different ways. We are forming partnerships and collaborations as part of research projects where we try and investigate things like what is the economic impact of spotted wing Drosophila right now, and understanding in what types of circumstances this type of technology would be useful. Also understanding in what ways the technology might be used. So who would be open to using the technology and on what scale, and understanding the scale in which it would be used influences the type of technology that we will develop. So we have several options for how we could build it. Some would be longer lasting and some would be less long lasting. And this is something where I think conversations with the experts, with people who are dealing with the problem, is important in shaping that decision making early on. And by building a relationship early on, it will enable us to have more informed conversations with regulators towards an eventual field trial and an eventual use. Kent?
Yeah, so with classic biocontrol, we've always got the issue of permitting. And in California, it's not just California, it's the US. And in the US, it's not just the US, it's Canada and Mexico. So have you been able to successfully get some of your insects through the permitting process relatively quickly, or is it usually a 2, 3, 4 year process?
So we don't have experience of doing that yet because we're still in a development phase. So this isn't something where we're going to have a technology in the next 2 years ready to be imported. However, we have been considering whether it makes sense from a regulatory point of view for us to build the technology separately in different locations, if that then eases the process of getting towards testing.
Is there any way you can label this to the regulators as not being GMO, not being something that's been changed? Because that's got a connotation right now that just raises red flags.
Yeah. So I would agree that that having something non-GMO does make it easier. There are simply just barriers you don't need to go through. In this case, the main innovation here is GM. So we would have to rely on that. However, I was working at Johns Hopkins for the last couple of years before starting Biocentis. And during that period, I did import a number of transgenic organisms containing these elements into the US from the UK. That wasn't particularly difficult doing that within a research setting. And so forming a partnership with a research institute in the US, I think would be quite an easy way to import those insects and do studies within the US. And then it's a second type of permit before you get towards something like a field or semi-field study.
Thanks.
Any other questions for Andrew? Thanks, Andrew, and your team for doing presentation. We really appreciate it. This does seem promising technology, and hopefully we can work together to go through different hoops and bring this technology to work in the field.
Thank you. I don't know if Giorgio or Federico, you had something to add?
Yeah, thank you very much. And as Drew said, we're really looking forward. I mean, meeting people like you and speaking with stakeholders like you to learn more and design a product that really fits the needs and the purpose, right? Anyway, thank you very much for having us.
Thank you again. You're welcome. And also, let's open the floor. Basically, this is our, when you look at the agenda, this is our stakeholder summaries time and feedback time. Based on the number of stakeholders we currently have, we will not need to split into East and West groups. We'll stay as one group. And I'll hand it off to Juan and Cesar to sort of take comments, questions as one unified group. So, Juan.
Hello. Actually, we lost all our stakeholders. So what are we going to be doing now? This is tough. What I can say is what I just said a little bit earlier. This year, to the best of my understanding, we've had much lower pressure than what we've had in the last a few years. Things will likely change this year again. We're really excited about continuing to do our biocontrol work, as well as some of these other new technologies. Some of the attract and kill and some of the deterrent work would also be kind of interesting to look into as well. Yeah, I don't know. It's we're working. We're going to be working a little bit more closely as well with the two HENAs to make sure we present some good data if we get decent infestation this year for spotted wing on the year in the West Coast. So, Cesar?
So just an update. I wanted to give an update on what I have been hearing from the companies on the behavioral control part. I have been in contact with Andermatt. I mentioned they are having some difficulties getting all the states registered. So they have solicited the assistance from IR4 because they have to do some petitions, and that I think that costs money. So so I think IR4 provides some support to companies to move towards registration. So they asked me to write a letter and also complete a form in support of Combi Protect, which I submitted last week. So that's kind of where they are right now in that process. I'm hoping that they'll have the product registered by the field season, but they are starting to get more, it wasn't as easy as they thought it would be. And also with the ACTRA, Andy's on the call, but there's a meeting coming up with EPA to discuss switching how they categorize ACTRA as a insecticide and categorize it as a biopesticide. So that's where we are right now with those products. Things are not as easy as you think.
And Cesar, I can add to that. This is Anderson Hedgecock. So yeah, Cesar, he's been very helpful for both companies. And how do we navigate the path to either non-regulated status or even through registration? So with the ACTRA SWD product, it's really a blend of ingredients that we would consider to be flavoring agents that are regulated outside of the normal pesticide realm, and the EPA is very unfamiliar with. So that has created additional steps and hurdles that we're trying to walk through. So again, it's always more difficult than you think. And I'll leave it at that. We're very excited and very happy that this is very supportive of us and helpful in our conversations with EPA, BPPD, and then even going forward with our pre-submission meeting, as Cesar mentioned. So Cesar, thank you. And I'll keep you informed as I jump through this next hoop that they put out in front of us.
Thank you. Thank you, Anderson.
Thanks, Anderson. We have a question, for Kent. Any thoughts on whether leptoplina might be contributing to lower SWD pressure in 2022?
I think it's going to take at least 3 years after establishment, because there's just so much spotted wing out there. In fact, some of these low populations that the stakeholders are describing might be great for the parasitism impact if leptoplina and Ganaspis can sort out and survive, because they'll have fewer spotted wing. That's going to be a real test if they can stay in the different environments that they're being found in. I really believe that leptoplina is a good parasite. It's got a wider host range. That we talked about this in the past. That wider host range is bad in terms of classic biocontrol, in that it's not what you're supposed to release, but it's good in terms of establishment, because spotted wing gets very low and it can go over to melanogaster. Spotted wing is oftentimes outcompeted in the fruit system by some of these other fruit flies that come in, like melanogaster. So spotted wing is first. These parasites attack it first. And then in Asia, you get Asobara, the Bracconid, and others starting to kind of outcompete them at the end of the season. With Leptolema, if it works out really nicely to have Ganaspis come in first, and then Leptoplina being able to come in later and stay in the system when melanogaster is there, its numbers might be a little bit better. And of course, Ganaspis has got the benefit is that it really is sort of specialized on spotted wing, the G1, and Xin King and Kim will talk tomorrow about Matt's efforts to give this a new name. And so it might be an effective 1-2 punch in some regions. And in some regions, it may not establish. I'm most likely in one of the worst spots for it in California Central Valley. So my efforts were for you people, because I don't think it's going to be able to stand the hot, dry summers. Hope that answers the question. I talk too much. So.
Kent, what's the status with that with the G1 and the G3? Can we at some point rear G3 that is easier to rear, or what?
So when hopefully the whole rearing aspect of this difficult problem is not something that's going to be long term, because hopefully this is never going to have to go into an augmentation program, but that once established, it starts to build up its own numbers and reaches a equilibrium with the pest species. Right now, USDA APHIS is extremely risk averse. That's why I mentioned to Andrew the permitting process. You know, had that first permit gone through in 2016, we would be saying, yeah, we did it. We got Leptopolina, you know, established here in North America, and it spread throughout. But they would not allow us to release it because it attacked, you know, I think 9 out of the 24 species. GB3 attacked 4 of the 24, but really just 3. And it's possible it's already here in Canada. So Paul's group, other people in Canada are checking this out right now. Most of the material that's come back has been G1. The material we got from Washington, from Betsy, and it is G1, and it worked out to be G1 Tokyo, according to Fabrizio and Judith Stahl's molecular work. So at this point in time, I think G3 is kind of off the table unless it accidentally gets here.
Thanks, Kent. There's another question in the chat from Martha Flanagan about interactions between GB and LJ and effect on establishment.
So I'll answer for Shin King, but Shin King and Antonio Bionde did a lot of this work. So in the laboratory, under fake conditions, Asabara, the Braconid, is the most competitive. It knocks the others out. It doesn't discriminate. So it puts its egg into spotted wing that's already been parasitized by Leptopolina organaspis. And it develops faster. So you get 2 parasites in the same host, and the one that gets bigger quicker wins. So Leptopolina also doesn't seem to discriminate, and it develops slightly faster. So Leptopolina's got a slight advantage over Ganaspis in terms of development. And Ganaspis, though, does discriminate. It comes up to a spotted wing first instar that's been parasitized by Asabara or Leptopolina, and it goes and finds one that hasn't been parasitized by anything else. So what's good about that is that you don't get superparasitism. You have an insect that's out there and it's saying, okay, this has been parasitized, I'm going to find something else. And so that should overall increase total parasitism. So that's why we think Ganaspis and Leptopolina will work well together. We really don't want Asabara because that's not a good biocontrol technique. It's definitely a generalist, and it might disrupt the effectiveness of the other two. I hope that answered the question. So Ganaspis in the field in Asia was more common on spotted wing because it's a specialist. In the laboratory, Leptopolina has got a faster development, which makes it win in the laboratory, but maybe not in the field.
Kent, when you collected, you and Kim and others collected Ganaspis, the climate where you were collecting it, you were saying you're kind of worried that it's too dry in the San Joaquin Valley, but is it very, very different than here?
Yeah, so Shin King he's got this down and he's going to present it tomorrow.
Yeah.
Basically, when we were collecting in South Korea, we went from the top to the bottom of the country. And at the bottom of the country, it can be very dry and very hot. Not quite as dry as San Joaquin Valley, but very dry and very, very hot. They get their 105-degree days. Where we collected in China, in Kunming, it is much more, it's much more tropical. It's very, very far south in China. So, and we also had a colleague collect in Beijing and in Tokyo, the CABI group collected. So we found these two parasites in very different environments. And I think that has some promise to it. Plus, Xin King is going to talk tomorrow about, now that we have a better understanding about the Ganaspis system, to seek out Ganaspis in climate regions of Asia that might be better suited to climate regions in the United States. All we have to do is to show that it is a G1 strain that can cross with Tokyo, because we've got G1 from Tokyo crossing with G1 from China. And so it's the same species, whatever it's, oh, Xin King is here.
Yeah. Yeah, probably tomorrow I'm going to show you, we did some mapping. We just show where the wasp come from Asia and how we project where they're going to establish it here. So sort of kind of have to match modeling. So today probably don't have more time. We can show tomorrow where details about the mapping of the modeling result. Okay.
Thanks, Kent and Shen King. Do we have Betsy Beers on the call? There was a question for her in the chat.
Yeah, although oddly enough, there's Sarah Jones on my on my little window, but it's me.
So,
what was the question?
Yeah, I said, did you find Ganaspis in the Yakima Valley this past year? Jana confirmed recovery in Willamette Valley, which is slightly cooler and wetter considering surrounding vegetation.
We didn't look in the Yakima Valley, but the Yakima Valley is hot and dry. We did look in around the Tri-Cities. I guess you could define that as the lower Yakima Valley. But we also looked around Wenatchee, sort of in north central Washington, and we did find some Leptoplana japonica, but mainly in eastern Washington, it was Leptoplana hemiphroma. So so far we've only found Ganaspis west of the mountains, where it is cooler and wetter. Now that just could be a question of source versus has not spread there yet, or it could be a climatic deterrent, if you will, to establishment in the hot, dry interior.
Thanks, Betsy. Any other questions or comments? Last call. If not, thank you all very much. We appreciate your being able to join us today. And we will reconvene tomorrow at 1 p.m. Eastern and 10 a.m. Pacific time. And tomorrow we'll focus on, again, we'll go objective by objective, but focus more on the plans for this coming field season and coming year. And at the end, we'll again invite any feedback or comments from the board members, and then we'll adjourn around 5 p.m. Eastern time tomorrow. So at this point, one last thing I wanted to check with the Joel Forest and Southern IPM region team to see if there's a way to create a new link or something for tomorrow, so we have only one Sarah and everybody shows up who they are.
I just sent out a new email that contains the registration. So if you have come through as Sarah Jones, please follow the link in the email I just sent to register, and you'll get your own unique link.
And if you are a panelist, it should email you a link that you will use that would come directly from Zoom tomorrow, an hour before the meeting. So you should be able to get that again. If you have any issues, just let us know and we can send that to you again. I can actually go in the system and make it send it to you again. So, and I was going to tell you, Ash, there's also an option to convert this just to a regular Zoom meeting where everybody would just have the same link.
I think that would be better.
Okay, I think that's what I'm going to do. So I'll convert that. I'll
Just
send
one
that.
link.
Yeah,
Just one
I'll send
link.
that link to you guys. It will behave differently than it did today since it will be a Zoom meeting, but Joe LaForest will still be here for tech support tomorrow. So, and if we were to need breakouts tomorrow, it would give us that option because
No.
I just learned that in Zoom webinar, you can't even do breakouts. Did not know that till today. So I'm glad we didn't need that option today. But yeah, so I'll convert this meeting and I'll send you guys the link that everybody can use and it'll be the same one and there won't be 15 Sarahs.
All right. Thanks, Kel. I appreciate your
No
help there.
problem.
And thank you all, everybody. Thank you again very much. And thank you, the team bioscientists, for joining us and giving us an update on your work and plans. And see you all tomorrow.
Thank you again. Bye.
Thank you. Bye.
Thank you.